It's my pleasure to introduce our next speaker, Dr. Elaine Langevin, who was sworn in as the Director of the National Center for Complementary and Integrative Health on November 26, 2018. Before joining the National Institutes of Health, Dr. Langevin was the Director of the Osher Center for Integrative Medicine in Boston, which was jointly based at the Brigham and Women's Hospital and Harvard Medical School. She was also a professor in residence of medicine at Harvard Medical School. So Elaine has centered her research around the role of connective tissue in chronic musculoskeletal pain and the mechanisms of acupuncture, manual and movement-based therapies. Her more recent work has focused on the effects of stretching on inflammation resolution mechanisms within connective tissue. She received her medical degree from McGill University in Montreal. She completed postdoctoral research in neurochemistry at the Medical Research Council Neurochemical Pharmacology Unit at the University of Cambridge in England. And she completed residency in internal medicine and finished a postdoctoral fellowship in endocrinology and metabolism at Johns Hopkins in Baltimore. Today, she will present the work that NCCIH is doing. It's work that she is providing leadership, and NCCIH is providing leadership to develop an NIH-wide collaborative program on the concept of whole person health. It's a program that embraces both the collaborative and the innovative leadership values that I discussed in my presentation this morning. So I want to thank Elaine for her willingness to share the concept of what I consider, and I think many of us consider, to be a very exciting program. And I'm sure that there will be many more discussions about the potential directions and NIH-wide collaborations that will happen as a result of her leadership on this program. So Elaine, without further ado, I will pass the virtual podium over to you.
Well, thank you so much, Rick. It's really a pleasure to be here. And as Rick mentioned, I cannot say enough about the importance for us in developing our strategic plan of the input that we have received from many different ICs, institutes and centers throughout NIH, but especially from NIHS. And so I hope that you will see in what I'm going to talk about the impact of the thinking and the feedback that we have received from NIHS and how we developed our strategic plan. So I'm going to share my screen here. Okay. Let's see. Hello.
We're not seeing the shared screen just yet.
I'm not seeing yet. Okay, sorry.
There we go. Okay.
Yeah, except it's not straight going into, we need to perfect this technique, but how about now?
Perfect.
It looks good. Great.
Very good. All right. So I'm going to be talking about whole person health. And what do I mean here? This is a concept that we developed as part of our new strategic plan that we have just released back in May. And the tagline for our strategic plan is building a path to whole person health. And I like this picture here because, first of all, I think it's a nice picture about, nature. And also this path, is not totally smooth. There's been some difficulties along the way. And why is that? Why is the concept of whole person health challenging? It's challenging for a couple of reasons. First of all, because it has two components. It has a whole person component and it has a health component. Now, let's first talk about the whole person component. So in medicine, and whatever we do, and it doesn't matter what kind of science, whether it's medicine or another type of science, or even philosophy or mathematics, there's always these sort of countercurrents between analysis and synthesis, right? Analysis is when you break things down into smaller and smaller components. And then synthesis is when you put them back together to sort of make a whole. And I have to say that in medicine, we're really good at analysis, in biomedical science. From the beginning of the understanding of, say, biological systems at the end of the 19th century, we discovered how an individual is broken down into a digestive system, cardiovascular system, et cetera. And this structure has kind of determined the structure of our academic departments, right? And also our medical specialties. A lot of patients complain that when they go to the doctor, they get treated, go to the foot doctor for your foot and heart doctor for your heart. And it's hard to really see the whole. And within each of these organs, we have different cells and tissues. And then inside of cells, we have different signaling pathways and molecules. But we have kind of recently sort of catching up to this, that really we need to pay more attention to the integration of all of these various components. And I think that, throughout the 20th century, the predominant approach to medicine was really pharmacological, right? And it kind of, I think, was really heavily influenced by the very heavy sort of biochemical understanding of the body into molecules and cells and molecules. But increasingly now, we're starting to understand the importance of synthesis. For example, systems biology is a really good example of that. And also genome-wide associations, where we're starting to understand not just one gene, one disease. We very much have to understand the totality of somebody's genome, for example, to really understand what's going on. And we have to go beyond the person to the community. They really understand how the social and environmental factors contribute to a person's health or disease. So it's not really surprising, right, that it's not easy to synthesize and integrate, but we need to do that. We need to really sort of put a lot of effort into putting the picture back together. Now, what about the health component? And here I've put again some pictures of some plants, because I really like this image. If you look at the plant on the left, it looks healthy enough. And if you look the one all the way over to the right, it looks like it's got some sort of disease, maybe like a fungus. But what about the one in the middle? It doesn't look quite healthy, but you have a sense that, if it had better care, perhaps, maybe a little bit less water or a little bit more sunlight, it might go back to the one on the left. But once you cross over into disease, it becomes more difficult, right? You get a sense that there is less of, you may need to have some kind of treatment to kind of coax the plant back to health. But the boundary between healthy and less healthy may be a little bit more kind of reversible. And the same thing with people. When we talk about disease, very often there is kind of a barrier, and I've represented this kind of as a broken line. But take, for example, diabetes. Very often somebody will have kind of a period of time where they might be gaining some weight, their diet may not be as optimal. They don't quite have diabetes yet, but they have what we call pre-diabetes, right? And so this is a very sort of dynamic situation where if the person would sort of pay attention to their diet, lose some weight, and I'm talking about type 2 diabetes now, you have a sense that the person might return back to health. But once you have crossed over into disease where you start to get into some end organ damage, it may be more difficult. So what we are beginning to understand is that when we think about disease, we tend to think about disease one organ system at a time, right? But when we think about health, it's more of a whole person kind of concept. And importantly, we know that a lot of the same factors, for example, a poor diet, a sedentary lifestyle, and psychological stress, importantly, contribute to the same diseases. For example, cardiovascular disease, obesity, osteoarthritis, even depression. And we know that, for example, if somebody has a sedentary lifestyle, they're more likely to gain some weight, and it may predispose them to osteoarthritis, which then it makes it more difficult to exercise, more difficult to stick to a diet. They may become more depressed and less socially engaged. And so we know that these different diseases are interdependent in their predisposing factors that predispose to them. We also know that the same interventions, a combination of self-care and a multi-component interventions involving psychological, nutritional, and physical interventions can help when given at an early enough stage, to reverse some of these factors that then lead to disease. So it's really about prevention. But what we know is that because we're so much more focused on disease, we understand the factors, the pathophysiological factors that lead to disease a lot better than the factors that lead to health restoration. And so as a consequence, we don't really understand very well the mechanisms of this phenomenon of going back towards health. Think, for example, of COVID and the nearly 20 to maybe even 40% of patients who do not regain their health after a documented acute infection. It's obviously very important to understand why patients with the post-acute COVID syndrome continue to experience symptoms. But it's also really important to understand the process of recovery from COVID. Similarly, in patients who are successful in reversing early diabetes by improving their health or increasing their physical activity and losing weight, what are the healing processes that take place in restoring the normal metabolic function? And much of this remains unknown, as we know much, much less about health than we know about disease. And one reason for this is that health is complex and involves the whole person. Now, there's a reason why this is really urgent right now, because we are facing an unprecedented reduction, actually, in health expectancy in the United States now for several years in a row. And while this is all going on, we have this kind of convergence of multiple crises. For example, the opioid crisis, the pain crisis, the pandemic, the obesity epidemic, climate change. And we've come to the realization that a lot of this is compounded by the effect of social economic disparities. And all of these crises have really galvanized us to better understand the importance of the environment as a determinant of health, both the physical environment where people live, housing, local differences in air pollution, noise, crowding, food access, as well as the social environment, violence, crime, equity, justice. And importantly, we need to understand these factors, not just one at a time, but also how they relate to one another and influence levels of sleep, stress, and depression, as well as cardiovascular, respiratory, digestive, and musculoskeletal function. And similarly, we need to understand what social and environmental factors can be protective and restorative, how access to healthy food and nutrition education influences obesity and metabolic function, how access to sidewalks and safe bike paths influence physical activity and levels and musculoskeletal function, how access to yoga classes and green spaces can help with stress management. So this is how we have combined sort of this thinking into what we call our multi-level whole person health framework. And the way we define this is empowering individuals, families, communities, and populations to improve their health in multiple interconnected domains: biological, behavioral, social, and environmental. And again, as I mentioned earlier, the impact from several institutes and centers at NIH, including the NIEHS, as well as the Institute of Minority Health and Health Disparities, nursing, child health and human development, aging. A lot of these input from a lot of these institutes has helped us sort of shape this concept from whole person health for a whole person health framework that underlies our strategic plan. So these factors are really kind of important conceptually, but how do you operationalize this? And this is where we've had a lot of fun kind of trying to come up with a framework. And again, this has been very much, I'll mention a little bit later, a working group on whole person health that we have sort of convened that where we've had wonderful input from NIEHS in terms of how to organize the various factors that may contribute to either worsening health or improvement of health. And again, this really kind of borrows from the concept of the exposome, right? Which is really sort of, it's not just about individual factors, but it's the totality of factors that may influence health. And especially thinking about the environmental exposures, both chemical and non-chemical, such as, for example, noise, crowding, and socioeconomic factors. So thinking about, for example, the various factors that we know can be affected by these various sort of environmental exposures: metabolic dysfunction, endocrine dysfunction, oxidative stress, genetic and epigenetic factors, cardiovascular and respiratory function, and immune dysfunction. We know that there's a lot of different factors that can be affecting these various types of factors. But what I'm going to be focusing right now on both the effect of environmental toxins as well as psychological stress. And the reason why I want to focus on this at first is because, first of all, at NCCIH, we are very much concerned with the effects of psychological stress, and also about methods that we have for managing the psychological stress. We feel that understanding better how psychological stress can be managed can go a long way towards understanding how we can mitigate some of the possibly sort of compounded effects of stress, and also various other factors that may impact immune function, for example, or metabolic function or oxidative stress. So do we have evidence right now in the literature that, for example, some effects of environmental toxins may be additive to those of psychological stress? Do we know that this actually happens? So I had actually a lot of fun looking through the literature on this and trying to search for studies that actually show this, and found remarkably little. I think that this is an area that really needs more research. Interestingly enough, we found one paper back in 1996. I can't quite see if it's 96 or 98, but anyway, this is a very interesting paper where this is a study in animals that looked at the effect of a combination of exposure to DDT in the animal's food, mice, with restraint stress. And what it looked at is the interaction between these two factors. And as you can see here, if you look at the controls that did not have any stress, right? If you look at increasing exposures of DDT, there is, and what they're looking for here is a plaque-forming cell assay in mice that have been priorly immunized to sheep red blood cells. So they're looking at the spleens, and they're looking at the effect of IgM on these splenic cells. And so you can see that that there is really, that the DDT by itself is really not affecting this plaque control forming assay. It's an effect. It's a reflection of the robustness of the immune response to this immunization. But then, if you look at the effect of the stress, so this is restraint stress in these animals, and at various different types of stress. So here they're restraining the animal for 3 hours at 4 degrees. Here at 6 hours, 24 hours, and this particular one at the bottom, 1 hour, but repetitively for 5 days. And you can see that these various amounts of restraint do have an effect that becomes statistically significant down here on this assay. But when you combine the stress with the DDT exposure, you see that the effect becomes more pronounced. So this is interesting because it really points to an interaction between the environmental exposure, which by itself was not enough to have an effect, but combined with the stress, affected the immune function of these animals. There's also a couple of other examples that we've been able to find in the literature, looking at, for example, here, chronic social stress in animals in pulmonary function exposed to a variety of different of ambient fine particles. And you can see here that there's a variety of different indications of lung function. So these are compared with the stressed versus the non-stressed animals. The stressed animals had a greater reduction in, for example, here in peak inflammatory flow, actually not the peak inflammatory flow rate, but the inspiration, tidal expiration, inspiration, expiration, and then the peak expiratory flow rate, minus 3.9 versus 0.13. So you can see that, and as well as total volume. So these mice, pulmonary function was impaired in the stressed animal, but not in the non-stressed animals. So it points to an interaction again between the effects of the environment, exposure to breathing the particles, and the social stress. This is also suggested by this study in humans, where parental stress increased the detrimental effect of traffic exposure on children's lung function. Here is looking at the FEV1 and FVC in low parental stress versus the high parental stress. So again, I cannot stress enough how few studies we've been able to find in the literature to look at these types of interactions. But what we did find was suggestive. And very interestingly enough, we were not able to find any study where this type of interaction was mitigated by a stress management intervention. So this is an area I think we think there's a big gap in the literature about this. So looking at what could be the effect of stress management, if indeed there is an interaction between the toxins and the psychological stress, the effect of these, if there's a common mechanism by which these two might act metabolically or another type of, or genetically, for example, or physiologically, could stress management sort of take the edge off and perhaps prevent some of the damage? Now, we know that we have a fair amount of evidence that stress management in humans can have an effect on some of these various types of factors. And one of the types of stress management interventions that is very well studied now is mindfulness-based stress reduction. You can see that, for example, there's various different ways that people can do stress management, from relaxation techniques, for example, that were developed back in the 1960s, just by a simple relaxation response, deep breathing. There's there are techniques such as meditation, that are derived more from sort of Eastern types of practices like yoga or in China, Tai Chi. But there's been an effort to kind of standardize some of these techniques into methods and techniques that can be replicated across studies. So we're just starting to see these now meta-analyses that are starting to come out of where there's enough data on enough studies that you can see that if studies that have used a mindfulness-based practices to look at inflammatory markers, and this is in humans, and you can see each of these individual studies here in this meta-analysis does not have a significant effect, but when put together and in this meta-analysis, you can see that you have an effect size around -0.2 favoring the mindfulness. So these are not large effects, but again, if you're just trying to sort of take the edge off, it may be important in this case. There's another meta-analysis looking at the effect of mindfulness meditation on telomerase activity. And you can see again here sort of small to medium-sized effects on telomerase activity in these 4 studies here that have looked at the effect of meditation in various different types of settings, overweight, obese, dementia carriers, and chronic fatigue. So it's a beginning. A lot of this evidence still kind of needs to be bolstered, but it's encouraging that we can do something about some of these effects. Here's another interesting study. This was done in normal glycemic individuals that were trained to do diaphragmatic breathing and to look at the effect of this on postprandial heart rate. They were fed in a high carbohydrate meal, and to look at heart rate, plasma insulin, and also antioxidant potential down here. And when you do the diaphragmatic breathing, it helps to relax, and also it increases parasympathetic activity. So you can see it's not surprising here that their heart rate was a little bit lower, but also their insulin, plasma insulin was higher, and their antioxidant kind of measurements were global antioxidant potential in plasma was reduced. It was improved. So this type of study, I think, is interesting because it suggests that a very simple technique such as diaphragmatic breathing could have an effect that really might sort of overall kind of reduce somebody's sort of oxidative stress following even a simple meal. So what about other aspects of the diet, for example? It's kind of not difficult to imagine that the foods that we eat may compound sort of some of these effects of environmental toxins. For example, if somebody eats a very high fat diet, mostly sort of fast food, not a lot of vegetables, not a lot of antioxidants in the diet, that could perhaps exacerbate some of the metabolic dysfunction. But what about protective factors in the food? And one area that has been a great deal of interest is fish consumption, right? Because we think about fish as being healthy food, but unfortunately, fish carries some, I'm sorry, it says lead here. It's not lead, it's mercury. So anyway, if you look at this particular study, that if you look at individuals who had who eat a lot of fish, and look at the effects on antioxidant status here on both the oxidized to reduce glutathione ratio as well as the redox potential. These are individuals here who have overall, and you can see that the exposure to lead reduced these two values. And then if you look at those people who had a low versus high omega-3 index, you can see that the effect of the lead was only observed, the significant effect was only observed with those that had low omega-3 index in their plasma. So it looks like having the increased omega-3s somehow would mitigate the effect of the mercury in the fish. So what about physical activity? And of course, the effect of sedentary lifestyle we know is detrimental, and there's been a lot of studies showing that physical exercise is beneficial for a host of physiological outcomes, cardiovascular, respiratory, metabolic, etc. But when you're looking at acute exercise, it becomes a little bit more complicated, especially when you're looking at something like oxidative stress, because we know that exercise itself acutely can cause oxidative stress. It can even cause inflammation, depending on the amount of exercise that one does, right? And so there seems to be a sweet spot between the amount of exercise. Excessive exercise can actually add to the oxidative burden in the body. And there seems to be this kind of bell-shaped curve that a moderate to sort of vigorous level of exercise is definitely can be beneficial, especially in the long term if it's gradually built up. But excessive exercise can actually be negatively impact health. Now, access to areas, for example, to exercise outdoors can be very important too. And this is an area where in the pulmonary literature, for example, there's been a lot of attention paid to the amount of particles, for example, in air pollution that one breathes during exercise that can counteract perhaps some of the effects. And so access to green spaces and clean air would be very important here in understanding the benefit of exercise and how can we sort of really sort of promote that. So as you can see here, I mean, this whole, exposome and the interactions between both the negative factors and the positive factors and protective factors and health promoting factors, we think is very, very important. And here, this is where we would be very excited of the leadership of NIHS in the areas of understanding the exposome. And we would be very, very excited in collaborating with in collaborations that would really look at this sort of bidirectional direction of understanding the environmental factors from a health promotion point of view. Now, I just want to briefly talk about a couple of trans-NIH initiatives related to whole person health. One is the Bridge to AI Common Fund Initiative. The other one is the Trans-NIH Working Group on Resilience, and then finally, the Trans-NIH Working Group on Whole Person Health. First of all, Bridge to AI. This is a common fund project that is really geared towards producing some examples of data sets that would be AI ready for artificial intelligence, and that to kind of bring the community together and really sort of develop a platform for analyzing these data. So the importance of this project is that it really is based on the formation of multidisciplinary teams that would sort of combine data experts, artificial intelligence experts, engineers, and also clinicians to sort of define what we call the grand challenges, questions that we are not able to solve using our current methods. And we really need sort of a boost in methods development, especially for these very complicated problems. And at NCCIH, we are very excited. We are partners in this area, and we think that one of the very, very important challenges that could be very amenable to such an approach is what we call salutogenesis. Imagine that here is I've represented here a hypothetical network. It could be a metabolic network, for example. It could be an immune network. And if this network sort of gradually undergoes sort of a pathogenic change and now becomes sort of distorted, and you can see here that this kind of the network has sort of shifted from a healthier state to a less healthy state. What happens during salutogenesis or health restorations? If this network is coming back towards the healthy state, is it basically pathogenesis in reverse? Or do specialized sort of pathways or molecules or groups of molecules need to be activated in order to bring the individual back to a greater state of health? We don't know. We really do not understand this process very well. And we think that it's likely quite complex. And for that reason, we think that the Bridge to AI is a really nice platform for testing this type of thing. And one of the reasons for this is we know living organisms are organized into multi-scale interdependent networks. For example, a society can be viewed as a social network where each node represents an individual, and then what magnified is itself a network where each node represents an organ, which is also a network of cells and pathways and molecules and so on. And that the web of life represents networks within networks. So how can this help us understand the process of restoring health? Well, we know that multi-scale networks not only can self-organize, but also have the potential to evolve and grow through the emergence of patterns of higher complexity in response to challenges. And so emergence is a very important concept, and it's defined as the abilities of components of a network system to work together to give rise to unexpected, new, and diverse behaviors that are not present or predictable from its individual components. And this can happen from the top down or the bottom up. Examples of bottom-up health restoration processes could be immune responses, for example, epigenetic changes or microbiome adaptations. And these types of processes happen all the time without us being aware of them, but they can have a profound effect on the health of the whole person. Examples of top-down processes would be changes in behavior, or societal changes that would involve conscious decisions on the parts of individuals or groups of individuals. And these can also have profound effects on health. So this is why we think that a complex systems approach through the bridge to AI would be very important. And it also really points to another concept, which is that of resilience. And we're very excited that there's now a trans-NIH resilience working group that is led by Dr. Laverne Brown at the Office of Dietary Supplements, who she's been interested in leading this. And so now there's a lot of different ICs that have come together in this working group. And the efforts of the working group have been centered around defining and conceptualizing resilience, designing a resilience research design tool, and coming up with a definition of resilience that can be used across NIH, and then and also listing a lot of all the different funding opportunity announcements throughout NIH and all of the various different ICs that are working on this that have resilience as a component of them. And so the definition of resilience that this group has come up with is that resilient encompasses the capacity to resist, adapt to, recover, or grow from a challenge. And you can see here that there is this system that this resilience kind of acts upon, or could be either a component in the environment, in the community, the individual. The challenge might have a variety of different components, so the magnitude, duration, the type of stressor, and the reaction of the individual might vary from resisting, recovering, adapting, or recovering but worse than before, or collapsing. So this is a very important field because it really sort of ties together a lot of different concepts that so far have sort of been and not really come together as a unified concept. The other thing that we've been doing, and this is something that NCCIH has been leading, is a trans-NIH working group on whole person health research. So what we have done is started to bring together a group of stakeholders. First of all, at NIH, we now have 12 different institutes, centers, and offices, and NIHS has been a very active part of this. And what we have done first is try to think about the types of challenges to doing research on the whole person. And this is complex. This is definitely not something that we can do, that we need to work on developing the methods to address this and doing this type of research in a rigorous manner. And so at the end of this month, on September 29th and 30th, we're going to have a workshop on methodological approaches for whole person research. And some of the things that we're going to talk about in this, and again, I have to say that the committee that has put together this workshop has had input from many different of the institutes and centers that form our stakeholder group. So we're very grateful for that. And what we're going to be looking at are, for example, how do you study interconnected systems? How do you study various, do research on how, for example, the gut and the brain, or the gut, the brain, and the nervous system, and the musculoskeletal system, for example, or many different systems together. It's challenging. It's not easy. And so, how do you also look at the effect of multi-component interventions on these interconnected systems? If you have, for example, a combination of nutritional, psychological, and physical intervention, for example, exercise, diet, and stress reduction, how do you do this type of research in a way that is rigorous? And so we really sort of gathered input from many different sources to build a very exciting program for this workshop. And I encourage you to, if you're interested in that, check out our website. It's on our NCCIH website, and it's free to register. The next thing that we did is we said, well, okay, we need to develop a framework for for whole person health. As I mentioned earlier, there's so many different factors that enter into the health of the whole person, that it can be overwhelming. So how do you organize such a thing? And importantly, how do you develop a set of common data elements that could be used in a uniform manner to examine health across the whole person in all of those various domains, biological, behavioral, social, environmental. It's definitely a challenge, and it's something that we've started to tackle with the help of our whole person health working group. The other thing that we are really interested in is developing some technology that would then be able to synthesize this information that from the framework and put it in such a way that it becomes accessible for both for patients, for patient care, as well as for research. We know that for patients, for example, it's very difficult for them to understand, to get the data from their health records is not always very accessible to them. And more people are getting health data from their wearable devices, Fitbits, sleep sensors, et cetera. And then there's also information that from geospatial records that could be very interesting and important if it could be integrated. And of course, data from electronic health records. And so we think it might be very exciting to develop a platform that could then integrate all of these data in such a way that it could result in sort of actionable recommendations for patients for their self-care, for example, that could be appropriate to their socioeconomic circumstances, and then link them to resources available in their communities where they could sort of take some actions that could help them with various aspects of their life, such as exercising more, improving your diet, or reducing stress. And finally, we're very interested in doing some portfolio analysis of various different types of integrated approach to understanding the type of research that we're funding. This is just an example of a network map that we've done at NCCIH, looking at the grants that we fund. And you can see here that they've been sort of mapped out into the various different systems of the body, as well as psychological, social, environmental, developmental, immune, et cetera. And what you can see here is that the grants that are in pale blue are those that map to only one system or one category. And those that are in the dark blue are mapped to two categories. Those that are in the yellow map to 3, and those that are red in the center map to 4. So this is a way to understand about what type of research we're funding that has an integrative component that looks at several different aspects of a person. So we think this will be helpful to understand how to shape our portfolios to have a more sort of integrative kind of span or scope in the future. And eventually, after all gathering all of this information from our stakeholders, from our workshop, from the data elements, the technology, the portfolios, eventually we want to work with our group to develop some funding initiatives. We think that this is going to be an area of research that will grow, and also that has the potential to really sort of spread throughout NIH. Or notice that our stakeholders here in partnerships in this group are more what we call institutes and centers that are what we call non-categorical. So, for example, National Institutes on Aging, biomedical imaging and bioengineering, child health and human development, dental and craniofacial, environmental, minority health, nursing, National Library of Medicine. We have the Fogarty International Centers, Center for NCATS, the Clinical Translational Research, NCCIH, OBSSR, which is behavioral and social sciences, disease prevention, dietary supplements, women's health, and nutrition. But we think that eventually, and we purposefully kind of restricted ourselves to a group of these sort of non-categorical ICs because we felt that these were the institutes and centers that had already kind of an integrative focus, that were not sort of specific to a disease or an organ system. But in the future, we really feel that this could apply because to all across all of NIH, because even institutes and centers that are, for example, heart, lung, and blood, there's a lot of efforts to understand how, for example, the heart or the lungs, for example, the effects of exercise on cardiopulmonary function. It really does not it goes way beyond the hearts and the lungs. And so we think that the concept of whole person health can really be kind of universal in a way. So I'm going to stop here, and I would love to entertain any questions or comments.
Elaine, that was terrific. So let's see. Why don't we? Let's see if it's going to take a little while, of course, for people to kind of muster up their questions, queue up their questions. And while they're getting ready to ask their questions, I'll make a comment. I was very pleased to see the community part of the whole person health. And so we know a lot already about, as you pointed out, about fish oil and exercise and a whole variety of different things. So are we spending enough time focusing on the community engagement and implementation science to actually bring some of these things that we already know to the benefit of communities? Because we're going to be increasing the amount of information we get. And as we discovered, for example, very effective vaccines. Once we develop this, it doesn't necessarily mean that people are going to be taking it. So question is about community engagement. Are we doing enough?
Oh, that's such a great question, Rick. And in fact, implementation and implementation science is such an important piece of this. You know, for even simple things like, well, relatively simple things or straightforward things. For example, at NCCIH, we're very much involved in opiate prescriptions for chronic pain. This is something we know that opiates, for example, should not be the first line treatment for people with chronic low back pain, for example. But nevertheless, it continues to be prescribed. And we know that non-pharmacological interventions should be tried first. But the problem with that is it's more complicated to do. It's not necessarily reimbursed. There's a lot of obstacles to doing these sort of slightly more complex things. Dietary interventions, they're not easy to implement. So this implementation, I think that needs to involve the community. And as you said, a lot of these things are happening at the grassroots level. People want to do it, but the healthcare system is somehow not up to the desires of the community. So meeting the community where they are and working with them to really push for implementations of these things, I think this is extremely important. Yeah, so thank you for the question.
Sounds good. Well, as I predicted, the questions are lining up. And it looks like Andrew Geller from the EPA has had his hand up first. Andrew, do you want to unmute and ask your question?
Thank you, Rick, and thank you, Elaine. That was a wonderful talk. I wonder, as you are surveying what data are out there, if you're looking at both the environmental justice data where there's looking at health disparities and particularly exacerbation of health impacts with stress, in particular social stress and racism, stress of racism, as well as salutogenic factors like ecosystem services or natural benefits, and they're salutogenic factors. We've certainly been doing a lot in that area, and would love to chat if that would be helpful.
Oh, I would love to talk about this, and this is an area where definitely, if this could be a very great partnership, because we're assembling a group of sort of external stakeholders who really want to move in this area. So I absolutely, let's definitely chat. I think that we could really hopefully contribute to the momentum. I would appreciate that very much.
Elaine, we'll make sure that you have Andrew's contact information. So thanks for that question. It was a great question.
You bet.
Okay, it looks like Karen Vasquez is next. Karen, do you want to ask your question?
Sure. Yeah, thank you for that really enlightening talk. That was fantastic. Really enjoyed it. And I really enjoyed the idea of, and agree, of course, with the idea of whole human health and these studies. I think that's great. But one question, and you got to this a bit, but you mentioned how it's very challenging to do, robust studies in understanding sort of why does this correlate to this, and how does this interact with this system? And it's very, very challenging. I understand that, but if we don't, if we look at correlations, that's useful, obviously, and beneficial, but without understanding mechanisms. For example, I was very interested in your telomerase result, but what is the mechanism? Like, how does that happen? Why is that? What is the impact? What's going on there? So you mentioned you have a workshop on approaches. Do those include things to actually understand what's going on at the mechanistic level so that we can then utilize this information with much greater potential?
Yes, the first session of the workshop will be about that, how to study interconnected systems and at a basic level and mechanistic level. And then later on in the workshop, we're going to be more talking about, clinical studies, that look, and obviously this needs to involve basic and translational research. How do you move into a more complex system that we have less control over the variables? So the workshop will look at that.
And can you just remind us all when the date of the workshop?
September 29th and 30th. And the registration is on our NCCIH website.
And a link will be provided or something, we can.
Yes, on the website, you can see it's right there. Just click on it and register. It's free. And
Great, thank you very much.
You're welcome.
So I see that so Mark has just posted the URL for the NCCIH workshop and methodological approaches for whole person health. Elaine, I assume that's what you're referring to.
Thank you.
Okay, we got it. So Edith, it looks like you're next. Do you have a question?
Yeah, I was first of all, thanks. I think that was great. And I had a friend who used to talk about hardening of the categories instead of hardening of the arteries, talking about the way we do it. So it's great to think about a systems approach. I did want to bring up a couple of things, I think, and one is building off Andrew's. I would be concerned that in some of the examples, I know that this is early on of what we could do for stress mitigation, seem to be very individual focused, and I would have concerns when you take that individual approach about access, and if we might increase health disparities of certain populations for which those things would not be available. I thought, for example, your plant metaphor was fantastic, and if you haven't, you may have seen Kamara Jones, who uses the plant metaphor to show the different signs of racism, pointing out that depending on what soil you put the plant in, which will be a social determinant for structural factors, may impact that. So, and then I think my last was that it seemed like you were moving from primary to secondary, tertiary. I'd love, and I think there's such a room, you've mentioned this, thinking about some research again on primary prevention, on behavior change, on how we get people to uptake these. Rick's mentioned this. We are in prime example now of how difficult that is. And while we've built that base a lot, I think there's still a lot we need to learn about that. So that's all I have to say.
Oh, thank you for these comments. Well, I think in response to the first point you made about the individual focus, this is, I think, an area where the pandemic is, in a way, has helped us a little bit, because it had thrown everything. For example, some of the interventions that NCCIH we used to study that were always administered in person. And now we're finding that people are finding ways to administer these remotely, and also that these remote interventions can be delivered in groups, which kind of makes the whole, turns the whole problem upside down. We were very interested in kind of being able to deliver some of these interventions at a lower cost. And so people had already started doing, for example, acupuncture delivered in a group setting. And now people are even starting to do these kind of, using virtual reality actually to simulate the environment where an acupuncture treatment is being done. It's fascinating that you can, if not somebody who's never had an acupuncture treatment, but if you have experienced acupuncture, then after that you can kind of recall some of the effects of the acupuncture just by thinking about it. And it's very interesting. And so could this be now help deliver the intervention at a lower cost assuming people, of course, have the internet and, kind of capabilities. But I think there's a lot we're going to be doing differently after this pandemic. And I think that it's going to maybe in some ways help us to deliver the interventions in a way that can reach more people. It won't be quite so expensive.
Great, thanks, Elaine. We have 3 minutes left, and Trevor, how about if you take a minute and a half? And I noticed that Sharon Beard also had a question that she posed in the chat, so we'll give Sharon a minute and a half. So Trevor?
Really enjoyed your talk. I really enjoyed the concentric circles and different nodes. One node I didn't see on there, which might come as a sleep disturbance, was actually circadian rhythm. When I think about sleep disturbance, for example, I think about maybe 1/3 of the population in the US are shift workers. And what interventions can we use to tackle that sleep disturbance that they suffer?
Great question, Trevor.
That's a great point. Thank you. Yeah, we'll make sure that we put that in there. It's super important. Yeah, thank you.
Sounds good. Okay, in the remaining 2 minutes, Sharon, do you want to unmute and share your question?
Sure. It comes great after the question by Trevor there in reference to circadian rhythms, because we're talking about workers and shifts. My question was, will there be a focus on occupational safety and health impacts on work and health? Because I feel there's no way to talk about whole person health without the impact of work and health, especially health disparities of work, because we're seeing the impacts of that right now dealing with COVID-19.
Yes, absolutely. Yeah, we do have it in there somewhere in terms of, work safety, exposure during work, environmental exposures during work, but also the work-related stress. So yeah, absolutely. We'll have to make sure that it's part of all of this. Yeah. Thank you.
Well, we work with NIOSH on a lot of these types of issues, and we can certainly work with you to have the appropriate representatives from their research focus on looking at these types of issues, also hopefully participate in the conference.
Sounds great. Thank you.
Dr. Lane, I'll make sure that you have Sharon's email address. And I
Yes.
see Gary is back on, and we have like 15 seconds left. So let me take that time, Elaine, to thank you for an incredibly insightful presentation. Yeah, I think I'm speaking for all of us in the environmental health sciences community that we are looking forward to continuing working with you. So great presentation. Thanks for taking the time with us, and we'll be in touch.
Well, the appreciation is mutual. So thank you very much for all the great work you're doing.
Okay,
Thank you so much.
Take care. Thank you.
Okay, Gary, it looks like we're going to turn the virtual platform over to the acting director of DERT for your presentation. So
Yeah.
You're on.
Thank you. So thanks, everybody. I think this is the presentation by Dr. Langevin. Is that the correct pronunciation, Rick? It's a French name.
Langevin.
Langevin was excellent. And it actually aligns with a lot of our thinking around environmental exposures when we're looking at more than one exposure at a time and its impact on health. So I think there's a great deal of alignment there. So first of all, I want to thank all of you for being here today. I also want to express my gratitude to the Division of Extramural Research and Training, my colleagues who have worked tireless to keep our extramural research enterprise going strong and helping me in all areas to prepare for this meeting. Next slide, please. So today I want to start by introducing new staff and then show recent and upcoming DERT meetings, provide an update on some of our diversity, equity, and inclusion activities, and discuss updates on COVID-19 funding, and provide some insight into the DERT portfolio with a focus on climate change. So next slide, please. So first step, staff updates. Next slide, please. So you've heard Dr. Wojcik announce Sharon Beard as the new chief of the Worker Education and Training branch this morning. What I want to highlight right now, and we are very excited to have Sharon on board as our new director and chief of the Worker Education and Training branch. And Sharon just turned on our camera and you heard her speak earlier. We are also very excited about the selection of Carolina Medina as our new public health analyst in the program analysis branch. So in this role, she will manage a variety of projects, mainly IT and contract related. Carolina initially came to NIEHS as an extramural technical assistant with the Worker Education and Training branch, the branch in which Sharon leads, before moving to the program analysis branch. Before coming to NIEHS, Carolina was in the United States Army, where she held a position in logistics, as well as holding positions with Wake Med Hospital, Legal Aid of North Carolina, Costa Rica Comercial in Costa Rica, and the North Carolina Wildlife Resources Commission. Carolina holds a Bachelor of Science degree in Information Technology with a minor in Computer Security. So please join me in welcoming Carolina to this new role. Carolina, are you around? You want to turn your camera on and say hello, wave?
I'm here.
So congratulations on your new role, Carolina. Next slide, please. So next, I'd like to talk about some of the meetings that have occurred since our last council meeting in June and a few that are upcoming. Next slide. First, several meetings occurred between June and August. For example, the July 19th Diversity Supplement recipient meeting brought together about 40 grantees who have received funding from NIEHS Diversity Supplements. And we provided resources on future funding opportunities through NIEHS that these grantees can potentially utilize to grow in their careers. The meeting also offered networking opportunities and time for discussions, and I'll provide updates on our efforts to grow this mechanism later in this presentation. The Getting Smart About Sensors for Disaster Response Research workshop, which took place on July 28th and 29th, looked to produce research recommendations to assist NIEHS in meeting sensor technology challenges for population science aimed at disaster research, either natural or human generated. The workshop provided multiple suggestions to move forward on leveraging disaster scenarios for linking sensors to science and service. Dr. Les Reinlib in our Exposure Response and Technology branch can answer any questions you have about that meeting. So next slide, please. So upcoming meetings include advancing partnerships to improve worker health and safety that will take place on October 19th through the 21st. This workshop is part of the semi-annual Worker Trainer Program awardee meeting and will consider elements that are integral to forming successful partnerships among Worker Trainer Program stakeholders, including grantee organizations, community-based organizations, and state and federal agencies. And the workshop will also address topics like understanding expectations and formulating negotiations, along with other topics related to building and sustaining partnerships. And I want to note one other meeting that's on our slide here in December, the Superfund Research Programs Grantee meeting. It's listed on the slide that it will occur sometime in December, but that meeting has been postponed. So I just wanted to update you now. So please stay tuned for more information about that meeting. Next slide, please. As you're aware, NIH has had increasing interest and motivation to promote diversity, equity, and inclusion in the biomedical research enterprise, which underscored its creation of the UNITE initiative, as discussed by Dr. Wojcik earlier today. So I'll discuss some of the activities to support both the extramural research enterprise as well as internal workforce culture geared toward ending structural racism in the environmental health sciences research infrastructure. Next slide, please. As a reminder, the purpose of the diversity supplements is to enhance the diversity of the research workforce by recruiting and supporting students, postdocs, and eligible investigators from diverse backgrounds, including those from groups that have been shown to be underrepresented in health-related research. During the past couple of council meetings, we told you about how we increased the number of diversity supplement applications and corresponding number of awards, as well as increased funding to align with these efforts. We are also working to reduce the time to award. So next slide, please. So we have processed more awards this year than we have during the last 4, and we've kept our overall average number of days to award low. Now granted, in green, the 137 is an estimate. Next slide, please. Looking at this fiscal year's data by month, we have seen a steady decline since implementing the monthly receipt review dates in October of 2020. It's important to note that we have more data to come in for 2021. That's why on the last slide, that was an estimate. But we are pleased with these data to date. And I want to thank all of the DIRT colleagues for making this happen. Next slide. EHS has many other strong outward-facing efforts relating to diversity, equity, and inclusion, particularly relating to engagement of the extramural community. So I won't go into too much detail here, given that I discussed these when we last met. However, I mentioned the Diversity Supplement awardee meeting earlier. We have updated our web pages and conducted a workshop at ISEE designed to make clearer the NIH funding process. The Division of Extramural Research and Training also conducted 4 listening sessions with historically Black colleges and universities and minority serving institutions. Next slide, please. Rick mentioned this earlier in his talk, that we conducted these sessions to learn about barriers that researchers at these institutions face in being awarded NIH funding. And this is in alignment with the U in the Unite initiative, and that is to listen to and learn from our stakeholders' experiences. Some key themes emerged from the listening sessions, including the need for technical assistance from NIEHS with the funding process through additional understanding of grantsmanship and the review process, and the need to build infrastructure and research capacity. What stood out is the desire for funding opportunities geared to building this capacity. In addition, startup packages are very limited at these institutions, putting these investigators at a disadvantage early in their careers. So we're working on the next steps with recommendations and action items, and we'll keep you and the participants informed about next steps. Okay, next slide, please. So I know there's a lot on this slide, and it just really underscores all of the work that we're doing in the diversity, equity, and inclusion space. So the slide shows DERT's DEI activities within the wider NIH and HHS diversity, equity, and inclusion landscape. Our division supports several funded programs which promote diversity, equity, and inclusion efforts, including diversity supplements, which I mentioned earlier, the worker training program, and other funding efforts. Internal committees and activities promote diversity, equity, and inclusion in our extramural funding efforts and internal processes. So we have sponsored numerous trainings, listening sessions, and workshops, have increased diversity supplement funding, have implemented diversity and bias training for our reviewers, And we're also expanding communication, evaluation, and transparency of diversity, equity, and inclusion, including maintaining updated metrics. Our internal working group continually discusses and promotes ways to support diversity, equity, and inclusion efforts and to evaluate our progress in this area. So next slide, please. And as for our own internal work, we believe that it's important to not only address efforts with regard to diversity, equity, and inclusion in the extramural community, it's also important to tackle our own issues within our division and within NIEHS. So I want to highlight that we brought new training directly to the division. Staff are going to conferences and we have ongoing active discussions. The DERT Leadership Committee participated in a 2-day Arbinger Institute training called Developing and Implementing an Outward Mindset. This training is geared to help us be better leaders and see people as individuals and not as objects or obstacles to getting things done. It's all in the way that we treat each other. And we also support and attended for the 4th year running to the local Diversity and Human Resources Inclusion Conference. We've also participated and brought NIH Equity, Diversity, and Inclusion training to the division. And as I mentioned before, we continue to engage in active discussions related to equity and inclusion at our all hands meetings and branches, working groups, and informal meetings with staff. Next slide, please. So I want to shift gears now and talk some about our funding related to COVID-19. Next slide, please. So this slide shows the number of awards made through COVID-19 notices of special interest. NIEHS issued this funding opportunity announcement to better understand the role of environmental exposures in coronavirus transmission and COVID-19 disease incidence and progression. NIEHS has awarded 17 supplements thus far, and we awarded 14 supplements in fiscal year 20 and 3 in fiscal year 21. And we also awarded a total of 5 time-sensitive grants. NIEHS spent a total of approximately $1.2 million on time-sensitive awards. And we also spent a total of about $6 million on supplements. Most of the awards funded research seeking to understand how environmental exposures, in particular air pollution, affect COVID-19 susceptibility, spread, progression, and severity. Other funding sought to develop educational, community-based, or other public health strategies. Next slide, please. The Coronavirus Preparedness and Response Supplemental Appropriations Act of 2020 provided $8.3 billion package to fund the country's response to coronavirus. Our worker training program received $10 million from the supplemental appropriations, and these funds have been used to support the NIEHS worker training program, COVID-19 Safety Training Initiative, which developed resources on vaccines for workers and workplaces, updated primary curriculum to reflect workplace guidance and realities, and provided guidance on selection and use of portable air cleaners. And these tools can be found on our worker training program COVID-19 resource page. Next slide, please. Now I'd like to transition to a discussion of the NIEHS grant portfolio. Next slide, please. So this analysis was really motivated by the desire to understand trends in NIEHS extramural funding that could inform policy discussions and decisions for Dr. Warchik and the director of the Division of Extramural Research and Training. And today's presentation will include a very high-level overview of the science topics funded between 2016 and 2020. Investments over this period are stratified by science topics, grant activity codes, as well as solicited and investigator-initiated awards. And an in-depth discussion about specific science topics and projects is really beyond the scope of this analysis. What I'd like to do before moving on is to acknowledge an incredible team of individuals who helped work on this effort and will continue to work on this effort as we move forward to try to understand our complex portfolio. So I'd like to acknowledge Takara Chamberlain, Yusha Kui, Christy Drew, Arsha Gaboni, Astrid Hogan, Jackie Marzik, and Stephen Tushime. Next slide, please. So there are a few challenges associated with this kind of analysis that I'd like to bring to your attention. So any analysis requires us to choose between the breadth and depth of what we're searching for. We have approximately 1,200 active grants at any given time, and our mission is quite vast, ranging from subcellular processes to public health interventions. And we have coding systems in place that enable us to place every application in a particular scientific topic, but this is a rough process. As you all know, every grant can be quite complex, so forcing it into a single bin can be difficult. And I'll go into our coding in more detail in a minute. When we add on the fiscal analysis, things get somewhat more complicated. Grants are awarded for multiple years, can have multiple accounting numbers, and have supplements. So I'm going to talk about just under 2,000 grants today, but these require a number of different rows of data that need to be analyzed because we're talking about a number of exposures, a number of outcomes, and so it gets quite complex. Next slide, please. So in this part, I'll start with a high-level overview of the past 5 years of the NIEHS extramural portfolio. Next slide, please. First, I want to take a moment to describe the data that I will show you in the next few slides. The total count here is just under 2,000, as I mentioned before, distinct grants that have received any funding from NIEHS. And the cost data were provided by our financial management branch and aggregated, and scientific topics are assigned by DERT staff. So I'll go into a little bit more detail on that. Next slide. As you know from Dr. Warch's talk, we have several budget line items from Congress that are all shown here. Now, the green on the bottom is our regular appropriation from the Labor HHS Committee. Next is our Superfund line that includes both the Superfund Research Program and the Worker Training Program that comes from the Interior Department. Additionally, we get about $10 million each year from the Department of Energy for specific training. And finally, we've had some small amounts of disaster relief and COVID funding that you can see on the very top of the bar in 2020. So the total budget over the past 5 years has been around $2.2 billion. And the percent change over time from fiscal year 16 to 2020 has just been just about 14%. Next slide, please. So we stratified the portfolio by solicited versus unsolicited grants. And as you likely know, solicited grants are those awards that are made to investigators responding to a particular funding announcement. And unsolicited grants are often referred to as investigator initiative, and they are in response to NIH parent grant announcements. When we look at the number of grants, we see an approximately 60-40 split towards unsolicited. But the costs are reversed. An average of 53% of the costs are solicited. So these costs are largely driven by our centers and cooperative agreements, which tend to be more expensive. So the bottom line here is that in terms of number of grants, we fund more from our research committee in response to investigator-initiated announcements. But our solicited grants cost a little bit more because we tend to fund centers and cooperative agreements through our solicitation. Next slide. So here you'll see activity codes included in all our grant numbers, and we have grouped them together. For example, R01 equivalent and center cooperative agreements so that we can display them graphically. Next slide, please. So here, the bulk of our investments are in R01 type and center cooperative agreement mechanisms, with most of the costs for R01s, about 70%, coming from investigator-initiated awards. And nearly all centers and cooperative agreements are solicited. Looking at the pie chart, about 48% of total funding is through R01 or R01 equivalent grants. And about 34% is cooperative agreement and center grants. And at the bottom here, you'll see at the smaller area, about 1.3% are in support of research mechanisms, resource mechanisms, sorry, like here and our cohort maintenance grants that you heard Melissa describe earlier. Next slide, please. Now I want to shift gears a bit and talk about the scientific topics. Every application is coded by the program analysis branch in DERT. And the goal is to capture the science topic that most closely associates with the grant's main objective. There are over 70 unique codes, and you can find a number of these codes in our Who We Fund website, and feel free to explore that. Decision process for assigning the code starts with the funding opportunity announcement topic. For example, everything that comes into an RFA focused on the microbiome would be coded microbiome. That's intuitive. Then we look at the organ system, and then all other topics, notably different kinds of exposures like metals and pesticides are really not a driver for this classification system. And this is historical. More than 20 years ago, when this system was first established, the order and hierarchy focused on organ systems and not exposure. So that's something that we may want to take a look at moving forward. So there are many exposures, and many grants have multiple exposures, as I described earlier. But we'll focus on the exposures in our deep coding, which I'll show you when we get to our climate change discussion. Next slide, please. So here are the 70 scientific codes. And as you can see, this is a bit of a graphical challenge. Next slide, please. So these codes have been grouped into simpler categories. And so these are the organ-related categories that I described earlier with, the associated topics associated with each of those. Next slide, please. And then this slide shows the other categories, which could be explored more deeply with regard to investments made over time. And I was intrigued with Helene's presentation where she showed the program, the portfolio analysis, and how she mapped them to a number of different topics where grants had topics in common, where they were disjointed. I think some type of portfolio mapping like that would be very useful in helping us see where there is alignment and where things are related in terms of what we support. Next slide, please. Here we display science topics by activity codes, and we saw a few slides ago. You can again see how the most common grant activities are R01 equivalent, and those are shown, I'm sorry. I'm sorry, is this the right? Yeah, this is the right slide. So here you can see our largest category of investments is in carcinogenesis and epigenetics, genetics, and genome integrity. And we support these at about $356 million for all 5 years combined. And then the neurobiology comes in at around $260 million for all years combined. And some investments appear to be rising over time, such as reproductive and developmental biology and exposure research. And our hope is to analyze these data more fully to determine trends and what we invest in over time. And this will help facilitate our discussions around next steps and how we strategize in the future. Next slide, please. So this is the slide about activity codes that we saw a few slides ago. And you can see now here that the most common grant activities are R01 equivalent. And you can see that with the light blue line. And then our centers and cooperative agreements are in light green. You can see that the Superfund research program and the worker training, the worker education program are highly supportive of cooperative agreements and center grants. Next slide, please. So to summarize, the highest funded topic areas overall are carcinogenesis, epigenetics, genetics and genome integrity, neurobiology, and Superfund research program. And most topics are funded largely by R01 equivalent and secondarily by center and cooperative and small Rs, except for the Superfund and worker education, which are largely center and cooperative, and tools and technology, which are funded secondarily after R01 by SBIR and STTRIR. And nearly all topics are represented in both the solicited and unsolicited portfolios, except for worker education, which is only solicited. And the breakdown of representation varies, with more solicited Superfund and exposure research than unsolicited, and more unsolicited heart, lung, blood, immunology, and neurobiology, for example. And again, this is just a high level overview of what we support. However, this is a framework for which we can begin to dig deeper into our portfolio to truly understand what we're supporting, all the way from subcellular processes to public health and translational science. Next slide, please. Now I want to dive deeper into the NIEHS climate change portfolio. Next slide, please. And so for climate change, we looked at any grant activity between fiscal year 2010 and fiscal year 2020 using our deep coding processes that I described earlier relating to exposures, outcomes, and strategic plan goals. And this process was completed for all awarded grants and sub-projects and centers and cooperative agreements. This process yielded 263 discrete grants conducting 3 kinds of activities: the worker training program, which is primarily cooperative agreements that I described earlier, climate change research grants, there were 120 of them, and then climate change adjacent activities. And this includes small business, and there were 109 grants supported there. Next slide, please. So climate change research grant topics include those where the exposure of interest is climate change, extreme heat or cold, severe weather, food, etc. Climate change adjacent topics don't explicitly have an exposure related to climate change, but may be related to an initiative or processes related to climate change exposures. Next slide, please. So here's a broad look at the 3 types of grants that I will talk to you about today. This grant again shows a total of 263 new grants. And these are grants with the first year of funding. And they are depicted only once in the year that they were started. So you can see that many of the worker training program grants and adjacent grants started before 2010. So I want to look in detail at each of these three groups, the research grants, the worker training, and those adjacent grants. Next slide, please. So I'm going to start the discussion again with the worker education and training program, because they have a long and deep history with vulnerable populations, as well as climate and disaster response. Now, the NIEHS Worker Training Program has more than 30 years of experience in providing health and safety training to high-risk worker populations, including healthcare workers. The 36 cooperative agreements train a wide range of worker populations that include vulnerable groups such as tribal nations, day laborers, and the socioeconomically disadvantaged populations. And this program uses the latest scientific research to address many topics directly related to climate change and support the trainers who possess the ability and skills to incorporate, translate, and disseminate scientific data in ways that consider cultural literacy and multilingual needs of the trainees. Next slide, please. Now, I want to talk about the research portfolio. On this graph, we're showing you the most granular data that we have down to the sub-project level for our multi-program project grants. So each project is shown only once when it was first funded, again. And we were interested in what was behind some of these big spikes. So I'll walk you through some of the key drivers here. Please advance. So first, we have issued 3 climate change program announcements. The first one in 2020, and these were R21s related to climate change and health, to fund applied studies as well as general methods and model development. And then in 2019, we issued 2 funding opportunity announcements that looked at the environmental influences on aging, which really explored the impact of extreme weather and disaster events in aging human populations, as well as the basic biology of aging. Please advance. Okay, there were 13 R21s funded from that first program announcement that I mentioned earlier, and from 2010, and we had 5 R01s funded last year in the aging and climate change program announcement. Please advance. And then our ocean centers were announced in 2012 and 2018. And 2018 was a really active year for disasters. For example, hurricanes Harvey and Irene, as well as several major wildfires. So our time-sensitive program funded about 13 R21s that are directly relevant to climate change in that year. Okay, please advance. Okay, and finally, the GeoHealth planning grants. And GeoHealth is the Global Environmental Occupational Health Hubs led by the Fogarty International Center and co-supported by NIEHS. These planning grants were funded in 2012, and then the full hubs were funded in 2015, and some of them have a direct climate change focus. Next slide, please. So one of the benefits of more focused research program analysis is that we can use that deep coding data that we have for all our funded projects. And this allows us to count individual projects that address certain exposures or health outcomes. So on the left, we see that our most common exposures are extreme weather and climate change and air pollutants. But many other exposures are represented as well. And on the right, we see that a variety of outcomes are also represented in our portfolio. And some projects just simply focus on a mechanistic aspect with no particular outcome other than to understand the mechanisms associated with these exposures. I do want to note that these exposures and outcomes are not mutually exclusive, so they don't necessarily add up to the number of research grants. So next slide, please. So the detailed coding also helps us match our grant portfolio to other frameworks. For example, here, we look at the research agenda established in the 2010 climate change report. And notably, this report was a key driver for the program announcement back from in 2010 that I mentioned that supported climate change research with the R21 mechanism. So the report describes 12 key research areas, and we were able to map the research projects against those 12 areas. You can see here that several of the grants went to support weather-related morbidity and mortality and asthma, allergy, and airway disease. And I do want to note that again, that the numbers don't completely add up to some combination of exposures and outcomes. For example, the asthma, allergy, and airway disease includes both respiratory and air pollution. So the next slide, please. So the final group of grants that I mentioned earlier were those that are relevant for climate change, but didn't quite meet our narrow definition for the research grants. And these adjacent grants fall into 5 different categories. 42 are small business grants funded by the Worker Training Program to support disaster response in the field, including rapid information access and smartphone apps. And then 27 GeoHealth hubs that are in place do not specifically address climate change, yet are poised to be a part of global partnerships. And then the 15 enabling technology grants are either computational or exposure related. 14 marine-based toxicity grants that look at zoonotic toxicology, but don't specifically relate to climate change. And then we have 4 community engagement projects supported through our P30 and P42 center grants. These community engagement projects have clear expertise working with climate vulnerable communities. So next slide, please. So I'll end the presentation here, but I just want to note that clearly, you've heard discussions from Dr. Wojcik. You've heard comments from Dr. Langevin and others, address climate change in their talks today. So clearly, it is proving to be the great challenge of our time. And as you know from Dr. Wojcik's talk, there's a large NIH-wide effort underway to develop plans for the expected increases to our budget. And there's also an NIH-wide portfolio analysis underway to support this concept clearance. So what I talked about today was the work that NIEHS supported. And I do want to note that with both of these funding opportunity announcements, even though they were led by NIEHS, we had broad participation across the NIH in these. So these collaborations, the galvanizing other ICs around the climate change agenda has been longstanding and ongoing. And so we thought, today it was timely to share what we could now about, our programs here at NIEHS. And so next slide, please. And so I'll stop right here and we'll take your questions, and thank you for your attention.
Gary, terrific. Thank you for that overview. And let's see if we could stop sharing the slides, and let's bring up the council squares. And are there questions for Gary? It looks like Karen Vasquez has a question. She's right out, first one out of the blocks. Gary? Karen.
Hey, Gary, thank you
Karen.
for that update. Quite impressive. About climate change and the funding and resources you're putting into that type of research, can you give us an idea of the types of grant projects that are being funded? I mean, are these all retrospective? I mean, just sort of to give an idea of the nature of the research.
Yeah. I can just sort of give you some highlights of some of the things that we expected to fund under the R21 announcement.
Right. Yeah.
Yeah. So I thought that the presentation would be a lot longer than it was. So it was really beyond the scope to provide information about specific research projects. And I really would like to go more in depth to discuss those. But NIEHS was really interested in research to identify and map populations and communities at increased risk of specific climate-related diseases. I mentioned with this R21, we wanted to fund research that was applied. So that would be epidemiologic research. How are populations who are exposed to some of these climate change events like extreme heat, like extreme temperature change, wildfires, for example. How are these populations who are exposed to these things, what is their response to them in terms of disease outcomes? So we were very interested in that.
Yeah, but can I ask a quick question on that?
Sure.
So with the R21 mechanism, then do you plan like for future longitudinal studies via R01s or program grants, or?
Yeah, and that's a good question. And I think, Karen, these are some of the things that we're discussing. Rick talked about his approach to working with all of the IC directors and forming this Trans NIH working group on climate change. This group has a number of initiatives underway. One is a request for information that Rick described earlier, that will get information from folks like you in the extramural community on what we could be doing about climate change. We have an NIH-wide portfolio analysis that will describe what we've done across NIH. And taking all that information together, we will begin to discuss what approaches we can take to develop research programs that will address research concerned with climate change and health that span from what I mentioned before, basic science, all the way to translational work that will focus on adaptation and mitigation strategies to climate change.
Yeah, great, thank you.
So it's definitely a work in progress.
Thank you, Gary.
So Gary, before we take another question, Karen, I just want to emphasize a point that I made this morning. The RFI is on the street. So if there are ideas about what is climate change and health research, is studying basic molecular mechanisms, is this part of it, or is it primarily population-based science? Well, we want your ideas on this, and it's becoming clear that it's the full spectrum of different things. Looking at, say, epigenetic signatures that are a consequence of heat exposures, and looking at some of the molecular mechanisms that may be responsible for changes in reproductive capacity, similar to that article that I referenced this morning. So we want your ideas about this. So it's what's clear is that climate change and health, the portfolio of science is going to be pretty broad. And so make sure you put fingers to the keyboard and get your ideas in. And
Will do.
The group will be working on all these things.
Thank you.
Thanks, Karen. And I do want to note that Lindsay Martin included a link to the funding opportunity announcement that I mentioned regarding environmental influences on aging. There's both a population health component to that, but there's also a basic science component to that as well. And I think that's PAR 19249.
Thank you. Thank you,
Yeah.
Lindsay.
Great. Looks like Bob was next to ask a question or make a comment.
Yeah, thank you. Great presentation, Gary. Related to climate, I'm just curious, are indirect effects of climate also of interest? For an obvious example, or maybe not so obvious example, would be Zika virus, mosquitoes spreading to different parts of the world. People are going to use more mosquito repellents like DEET. What are the health effects potentially of that sort of exposure? Are those things going to be part of this initiative, or is it mostly direct effects?
Yeah, that's a good question. And as I mentioned before, the initiative hasn't been developed yet, but I would imagine that, just as climate change affects extreme weather events, that it is associated with an increase in wildfires. It also has an effect on infections, right? Infectious agents and the vectors for those as well. So I would imagine that could be a part of any discussion. And I see that Gwen put her camera on. Gwen, do you want to comment on that?
I just want to add to that to say that we're interested in the health effects, but also the adaptations. And so I think what you described might be, worldwide changes, either in behavior in terms of applying these protections or other adaptation strategies that people or communities are already employing, given that they're already living within, the changing climate, and then also adaptations for protection and prevention. We're getting input on those topics as well in the RFI. So if you guys have ideas related to adaptation science, we're happy to know about that as well.
Thank you.
Thank you, Bob, for
To the
that.
keyboard, send us your ideas. Great. Other comments for Gary? Other comments or questions for Gary? Well, Gary, it looks like
Yeah, I see a note from Katrina and Lindsay, thanks for posting the other funding opportunity announcement. Katrina noted the 2010 report emphasizes mental health and was curious how stress and mental health are reflected in the portfolio to date going forward. Yeah, that's a good question. And again, this was a really high level overview of what we funded that focused just extremely high level. And we hope to go deeper into the portfolio. And I have Christy on. Christy, do you have any awareness of any grants that focus on stress and mental health and whether it's reflected in our portfolio?
So there were, according to that one count, there were about 16 that, and again, this is at the project level, so it's more granular than a grant in some cases, that had something to do with some kind of either psychosocial stress or mental health. And a lot of those, I think, of the time-sensitive programs, working with the hurricanes and disasters in 2018 is my recollection. I'm not looking at the list. But yeah, there's some. I think that's one of the reasons we thought about mapping it against that research agenda, was just to sort of see, well, how, this is what we thought 10 years ago. Are we able to do these things? Have we, without many, targeted announcements. So I think, again, this is just a backdrop of what may be coming in the special council session, but probably we wouldn't get too much in too much detail of the NIEHS portfolio at that point. So thought it was an opportunity to share what we found with you today.
So Katrina, this is Rick. I just want to chime in here that the director of the National Institute of Mental Health is one of the other IC directors that is part of the executive committee. Josh Gordon is intensely interested in studying the mental health impacts of climate change. And Eliseo Perez Estable, the director of NIMHD, very interested in the health disparities, psychosocial stress related to climate change and health. So lots of different areas of focus. So looking forward. So we'll see if we can include these topics as part of the portfolio going forward. I see that Gwen has her camera on. Gwen, do you want to add anything?
I just wanted to say that some of the early or some of the targeted funding announcements that Gary spoke about were multi-institutes participating, not just NIEHS. And so when applications come in on these topics, there's a referral guideline approach where they get assigned to other institutes. And in those cases, the institutes themselves make decisions about whether to fund or not. That is why I think Rick's idea about having the next program be squarely NIH wide, and then doing our best to encourage all the ICs at NIH to be part of this will be reflected in the future goals. NIEHS can't do it all, shouldn't do it all. And I think in the portfolio analysis that it was beautifully done. So thank you very much for sharing that today. Really gave us an idea of not only where the grants were, but also some of the challenges to, make sure that the research going forward is broad and really covers the full span of the topic.
Thank you, Gwen. Any other comments and questions?
Gary, just one other comment that I'll make.
Sure.
That we're still shaping this as what's the future going to look like, and there are some comments that have come in as part of the RFI to include part of this for the intramural research program. So clearly we have a number of very talented investigators that are part of the intramural research program at the NIH. So we'll have to figure out how to craft a component of the research strategy for both the intramural as well as the extramural programs. So lots to do, and actually I can thank Gwen for her coordination efforts, Josh Rosenthal and Aubrey Miller. They've been very busy. And actually, Gary, thanks to you, and I see Christy and all of her collaborators working on the portfolio analysis. I still have a number of questions which we'll be meeting on, but I think this is a fabulous first start. It just illustrates the great capabilities that we have within the extramural division around doing this type of analysis. So thank you.
Yeah, sure. And I also want to acknowledge the working group within DERT for all of the work that they've been doing. They've developed a framework for which we can begin to look at and address climate change and human health, that we've shared portions of that with the NIH-wide group. So this is definitely a collaborative effort for sure. I like to highlight that NIEHS has been a leader in climate change and health research for more than a decade now. Any more questions, comments? Well, thank you so much for your time and your attention. It looks like we have a break coming up. And this time, looks like we're ahead of schedule, and that hardly ever happens. So please, Irva.
Yeah, hi. I just wanted to comment on, the time-sensitive grants have been useful, I think, for a number of groups around the country, trying to get into the field, responding to some of the disasters that are happening. And I just wondered, I know under COVID, we actually saw how things can move very quickly. And a lot of agencies and institutes have figured out ways to move grants out even more quickly than say that those time-sensitive grants are. So I just wondered if there might be some discussion about ways to make them, it's definitely a lot quicker than the full cycle of grants at NIH, but having that lag between application and receipt of funding could be actually really beneficial if they're, some of the emergency sorts of ways of modes of operating that were instituted during COVID might be then able to carry forward for that or other mechanisms. Just a suggestion, a question.
Yeah, Irva, thank you so much for that comment. And I'm wondering if you had an opportunity to respond to the RFI, because those are exactly the types of, it's not just about the research, but it's also about the mechanisms and how we support the research that addresses climate change and how quickly we are able to respond. I think that that's an important comment, something that we should certainly take into consideration. And Gwen, I don't know, at the Institute level, have you guys started talking about that type of, those type of mechanisms that are designed to fund research more quickly related to disasters and climate change related events?
Sure, yeah. Since the inception of our time-sensitive program, I think folks in DERT, Claudia Thompson and Takara and others who are involved in that, we're always trying to, iterate that project and make it so that it meets the needs of the community. But it's true, it fits squarely within the approaches, I think, that are coming in from the RFI. We have built the portfolio in the time-sensitive area, not by intent necessarily, but because of all of the weather-related disasters over the last, 5 or 6 years. Quite a lot of applications come in there. So it is a topic that we're talking about and seeing how not only the way we do it, but maybe how other agencies do it might help us move forward and continue that.
Great,
and Gary, if I could just remind people that several years ago, NIH developed this urgent competitive revision mechanism that allows you to, if you have an existing grant, to expand the scope of the parent grant to include things like this. And we used those for the COVID, first and COVID request over the last couple of years, and turned around very quickly. We had a monthly review. Receipt date and a monthly review. And so we were able to get those out fairly quickly. The downside, of course, is you have to have an existing grant, but it is one tool in the toolbox.
Okay, thank you, everyone. I see Ravi has posted a link to the RFI as a reminder for all of you. So if you haven't had an opportunity to respond, there's still time. Okay. It's about 3:45 and it's time for our break. We have a 15-minute break this time, and we're scheduled to have a presentation by Karen Vasquez, who will discuss activities of the Council Working Group. So if there are no other questions or comments, we can go ahead and break for 15 minutes. Rick, do you have any parting words before we break?
No parting words other than we're right on schedule. So yeah, schedule, see everyone at 4 o'clock.
Okay, see you guys soon.
Bye.
Bye.
Well, welcome back everyone from your break. Hopefully you had some refreshments. And so to keep us on time, I'm going to turn the virtual podium over to Karen Vasquez, who has very kindly agreed to chair a special working group of council. She's going to tell us about some of the progress that she's made, I guess most notably in putting together this working group. So Karen, I'll turn the virtual podium over to you.
Okay, thank you. Well, first I'd like to thank Rick and Pat for allowing me some time in this meeting, and I won't make us overtime. I promise we'll stay on time. I just have, for those of you who were not at the June meeting, I'll go through just 3 slides, but I want to tell you a bit about our working group. And for those of you who were here in June, this is an update, and I'm happy to announce that we finally have our complete committee together, so we can actually start digging in and doing the hard work now. So let me just briefly go over this with you. I won't read through it. You can read the slides yourself, but we are I had been asked to chair, and I was honored to do it, this working group for anti-racism, diversity, inclusion, and equity. We've heard a lot about that today and all of the initiatives and things that are going on at NIEHS and elsewhere. But as we all know, this is a real problem and a very large problem. And so we can't do enough. So I think we are not redundant with Unite. We are not redundant with initiatives going on. We are additional because we need all of the help that we can to tackle these issues. And so that really is our charge. We are advisory to this council, and I am a member of council. So I'm sort of the liaison between council and the other members of the group who will report to council, who will then provide advice to leadership, such as Rick and Gwen. And Pat and Gary are very kindly joining our group as, how would we put that? Not ex officio really, but they're providing wonderful advice and helping me get through all this and put all this together. But we're not asking them to be on the working group per se. So let me go through that and I'll tell you what we mean by that. If we could have the next slide. We now have our complete membership for our working group. That includes 12 scientists from council, some not from council, some former members of council. We have representation from academia, industry, government, and representation from NIEHS. And I would just like to go through briefly, just to name and give credit to the group and the members who have agreed to serve for a 2-year term. I'm Karen Vasquez. You already heard from me. I'm at the University of Texas at Austin, and I will be chairing this, but that doesn't mean that I'm more important than anyone else on this group, because we're all putting in efforts, and they will be presenting in future meetings, because we have these subgroups broken down with chairs and so on. But I will talk on our behalf today, and then I'd like all of those members who are here to introduce themselves after the next slide, which is the last slide. So the other current or former members of council include Jose Cordero, Edith Parker, and Andy Shee. You've heard from Edith already today, and Jose and Andy are here, so I'll have them talk to you after the next slide. Members from a variety of places. You can see George Daston is from Procter & Gamble. I don't think George is here today, but George was here last time for those of you who were here, so you heard from him. We have Carmen Velez Vega with us today, and she's from the University of Puerto Rico. Craig Newshaper was planning to be here. I'm not sure if he is, but Craig has joined us from Penn State University. Ken Ramos from Texas A&M University. And Ken, I think a lot of you know Ken quite well. He's been very involved in NIEHS and former committees and so on. But Ken, I think, was not able to make it today. If he does show up, Ken, would love to hear from you. Peggy Shepard, who is working now with We Act for Environmental Justice, and Yvonne Maddox has also agreed to join our group. The representatives from NIEHS include Fred Tyson, who I think most all of you know quite well, and then Mary Diaz-Santana, who's a postdoc in biostats and computational biology, which is really helpful for us because our main charge here is to gather data and interpret large sets of data to see where we can improve. And also Mary, being a postdoc, is really helpful on our trainee subcommittee. And then I'd like to acknowledge and mention Pat Maston and Gary, who you all know, who have been really useful, providing me with advice and moral support and in every other way. And I'd like to give a really big thank you to Nicole Popovich, who is here. And so last time she wouldn't talk to us, but maybe she can talk to us this time. Nicole is incredible. So she really keeps us on track, organized. She's extremely generous with her time and is offering all sorts of support for us. She helps organize our Zoom meetings and takes amazing notes with working orders for everyone. And she's just, without her, I don't think that I couldn't do this. So thank you, Nicole, very much. Okay, if we could just go to the last slide. Thank you. So last time we discussed, and we had quite a bit of discussion about a variety of sort of subgroups that where we can tackle issues without just having to attack the whole problem at once. We have to just break this down as best we can. And so we decided on workforce, funding, both extra and intramural, trainees, and community engagement. Of course, these are very large and broad subgroup categories, right? So within that, we are going to define what we want to tackle as this small 12-person group, the best that we can do to provide advice to the leadership, to the council, who will then provide to leadership. I would really like to thank those members who have agreed to chair these subcommittees. And that would be Jose, who's chairing the workforce group, and he'll be working with Ken Ramos and Craig Newshafer on that group. The funding group, George Daston agreed to chair, which I think is great because he's in industry, but also has connections to academia. So he might provide insights that we don't always think of. And the members of that group will be myself and Edith Parker. And for trainees, Fred Tyson, who has been involved with a lot of trainee information and organizing groups and workshops. He's very involved with trainees. Fred has agreed to chair that. I think that's fantastic. And then Andy and then Mary will be in that group. And Mary is really essential in that group since she is currently a trainee. So we'd really like to hear from her. And then finally, the community engagement group, I think is just we got a fantastic group. Yvonne Maddox agreed to chair it, and then Carmen and Peggy will be working as members on that group. So with that, and again, I just thank everyone, but I would like everyone who's on to just please turn your videos on and say hi and tell us a little bit about yourself. And we'll start with Jose, because I know Jose is here.
Hi, good afternoon, everyone. It's good to see everyone. And I'm Jose Cordero. I'm the University of Georgia, and I'm delighted to be part of this working group.
Thanks, Jose. We're really happy to have you. And again, thank you for your willingness to chair the workforce subcommittee. Okay, Edith, I know you're here.
Yeah, I'm Edith Parker. I'm at the University of Iowa and also delighted to be part of the committee. Thank you.
Thank you, Edith. Andy, I saw you were here.
Yes, thank you, Karen. Andy Scher often speaks. I'm very happy to be here. Thank you.
And I don't think George is here unless he's on a phone call. George? No, George. Okay, well, it's a real pleasure for me to hear from Carmen, because this is the first time I'm actually meeting Carmen and since she's joined our group. She was one of our newest members. Carmen?
Hello, my name is Carmen Milagros Velez Vega, and I'm very honored to be here from the University of Puerto Rico Medical Sciences campus.
Yeah, thank you, Carmen. Craig, I know Craig Newshafer wanted to be here. I don't know if, oh, Craig made it. Great. Craig, could you introduce yourself?
Hey, Karen. Hi, everybody. I'm Craig Newshafer. I'm Dean of the College of Health and Human Development at Penn State University. Happy to be a part of this group. Looking forward to contributing.
Thank you, Craig. And I think that Ken Ramos is not here. Ken, if I'm wrong, Ken, please say hello. No. I also didn't see Peggy Shepard. Peggy, is Peggy here? And I didn't see Yvonne. No, Yvonne. Okay, well, Fred's here.
Hi, I'm Fred Tyson, and I'm a program director in the Genes, Environment, and Health branch, and I've been here for a long time.
Should everybody knows Fred. Okay, thanks, Fred. And Mary?
Hi, I'm Mary Diaz. As Karen said, I'm a postdoc at the Biostatistics and Computational Biology branch. And I am very eager and I feel very privileged to be part of this working group.
Yeah, we're very happy to have you, Mary, on the trainee working group. Okay, Nicole.
I'm here. Thank you so much, Karen. I really appreciate being able to participate in this working group and looking forward to everything we'll be accomplishing over the next 2 years.
Yeah, and thank you again, Nicole. Really I wouldn't do it without you.
Definitely my
really
pleasure.
You make our job very much simpler. Thank you. All right, and then Pat and Gary, I think we all know you, so you don't have to introduce yourselves, but thank you for providing me with advice and showing up to our meetings, and please continue. Pat keeps threatening to leave and say, no, you can handle it, but we really want you to stay, Pat.
Glad to, thank you.
Okay, thanks. Okay, so with that, we have a bit of time. If last time we had quite a bit of discussion about what we would like to see, and I think now that we have before we couldn't really speak to things because we did not even have our complete group assembled. Now that we have our complete working group assembled, my plan, and Nicole will help with this, is we plan to meet soon after this meeting. We wanted to do this first, and then we will meet as a group again and break down, since we're breaking down now into our subgroups, we're going to discuss as a large group, because everything is interconnected, right? And we've talked about that before too. These are artificial, really, subgroups in a way. But we're going to meet as a large group at least once a month and more if needed. And then the subgroups are going to meet as often as needed by Zoom, email, phone, whatever, however they want to move things forward. And our first goal is to decide maybe how many topics we can really address within each subgroup. Maybe we take 3 to 5 of the most important topics, and those members within the subgroup will manage that and come back to the whole group, and the whole group will have input as well. And then we'll come back to council and to you and everyone here for more input. So it's not like we're having the end all say all, we're just bringing up ideas that we think we can tackle in a 2-year time frame to provide advice. And so that's what we'd like to do, is come up with our 3 to 5 maybe most important topics within our subgroup. Then we're going to go back to Pat and get sort of an idea of what information is available to actually inform on those issues in a knowledgeable way, so we can move forward with data and numbers. And then after that, we will come up with, and again, the subgroups will work on it while we're, sort of during the month. And then once a month, when we all meet as a large group, we will all discuss and then bring it back to you at every council meeting. So we would like to, after we sort of get data, then we'll say, okay, here is where we see a gap in, X, Y, or Z, and would like to fill this in. Here are our suggestions on what may be. And then we'll present that, like I said, to council, and then council will fill those, fill that in further and give us feedback. And then we can provide actually a written working, it's sort of a live working document, but a written report to the leadership, to Rick and Pat and so on. So with that, I would just would like to welcome anyone to provide any suggestions, advice, concerns, thoughts at all that you might have. And next time when we meet, what I would like to do is have in our next council meeting, if we're allowed 30 minutes again, we would like to update on where we've been since this last meeting. And I would like the chairs of each subgroup to actually present at that meeting rather than me talking for them. So comments, suggestions, thoughts?
Nathan, can you, or our Paris, can you take down the, stop sharing? There you go. Thanks, sir.
Bob?
Thanks, Karen. Thanks for the introduction. I'm really happy that this committee's been formed, and I'm really excited about what you're going to recommend going forward. My one ask again is that Asian Americans be included. We've been traditionally left behind in academics and in conversations on racism, and that is my one concern. So I'd just like to make sure that that happens. I was very happy to see the Andes on the committee, though.
Yeah. No, definitely. I mean, I personally am thinking of this in a very broad way. So because we do leave out a lot of groups often, and Asian American is one, and we will definitely keep that in mind.
Well, the concern that I have is there's, in my life experience, the idea is that we don't experience racism, and that is a stereotype, and that needs to be addressed.
I agree with you. And I think that would be the case for every race, right? Would they feel of it? But yeah, absolutely. I thank you for that. And I actually have written that down, but I won't forget it.
Hey, Karen, I see that Yvonne has joined.
Oh, Yvonne?
Hi.
Hi, Yvonne.
Hi, everybody.
Hi,
Hey,
Yvonne, can you introduce yourself? I think that most of the group knows you, but could you just give a quick few sentences about yourself?
Sure. I've been on since 11:45 and I've enjoyed the council immensely. Yvonne Maddox here. I'm the vice president of my own family foundation now and CEO, and I guess I have all the positions, but I'm delighted to be a part of this working group and to chair the subcommittee, I guess, on community engagement. And I got to 2 wonderful questions that one of the council members asked, and a couple of comments made about how community engagement really should be looked at. So I'm honored to be a part of this. Thank you.
Yeah, we're so happy to have you, Yvonne.
Thank you.
Rick, do you have a question or a comment?
Well, just a comment. First of all, just wow. I mean, what a great group that you put together here. And
Yeah, we're excited.
so thanks for putting that together, and obviously you need to pay attention to Bob Wright's comments that he just made.
Absolutely.
Very, very important.
Absolutely.
The other comment that I'll make is that, you know, we have Trevor Archer, who is our representative. He's the co-chair of the I Committee. And so we may want to work it out so that there's some interaction between what Trevor is doing on his committee to get together with others from NIEHS on the committee. And we also am committed to ultimately hiring a diversity officer. That's part of one of the kind of the mandates coming out of the Unite Committee. So stay tuned on that. We haven't hired that person yet, but there's a number of things that will be happening here, hopefully relatively shortly. So once that person is on board, there may be a kind of an interface for you to make sure that things that are happening in Unite and across the NIH and across NIEHS, you know, get seamlessly integrated into the discussions that are happening in your committee.
Absolutely, that would be great. And last time in the June meeting, the question was asked, how will we align with Unite? Of course, we are not going to disagree with their findings, but we may have other issues, so we don't want to follow them as our template right now. But we certainly also want to, and this point was brought up, that there are so many initiatives going on. There are so many studies and data sets that we could use that others are like, we don't want to reinvent the wheel here or be redundant. So we want to tap into all of those, whatever, and Trevor would be a great connection for us. But as I said, we're not working in isolation, but we want to work in sort of our own sort of out of the box first, and then bring it back to tie in with everything else that's going on.
So we also have Talon Barnes, who is not one of the members of the PhD staff, but is one of our really terrific administrative support, part of the administrative support personnel here at NIEHS, who I'm sure he would be willing to chime in as well. He is also on the I Committee together with Trevor. But again, it's up to you. You're the chair, and
no, we absolutely will do that. We will absolutely bring them into our monthly meetings on occasion, and maybe we start with our next one would be useful. Maybe. Yeah, I'll get with Pat about that.
Mm-hmm.
Thank you. Any other questions or comments? Well, thank you all for listening, and I kept us ahead of time.
Great. Well, terrific. And it's great to see many old friends and colleagues. Actually, Yvonne, I haven't seen you. I've heard from you and emailed back and forth a few times, but I haven't seen you in quite some time. So good to see you all.
And I enjoyed your presentation. The director's report was fabulous. I got it on webinar.
Okay, well, terrific. That's good to hear that. So again, thanks, Karen, for all of the hard work you put into this, and thanks to all of the members for agreeing to serve on this committee. So any and all input will be, well, we're very interested in hearing what you have to say, because this is a topic that is very high priority for me and for the Institute, and it's not going away. So this will be something we will continue to work on.
Thank you.
Great. Thank you all. I look forward to, we'll put you down for 30 minutes the next time.
Yes, we will have the chair's report. Yes.
And hopefully we'll be doing this in person in our new Rod Bell Auditorium before it becomes our old Rod Bell Auditorium.
Right.
Okay. Thank you all. Okay, so I think we're running just a few minutes early. And let's see, Daryl, is Robin available? And maybe we can start her presentation 10 minutes early, and maybe we can finish 10 minutes early. Wow, what a record. We're going to end the Zoom session potentially a few minutes early.
So I'll introduce Robin, and then we'll give her the podium. So Robin Stanley is the
Mr. Rick and Pat and so on.
Can you hear me okay?
Someone needs to mute.
All right. So Robin Stanley is the head of the Nucleolar Integrity Group in the Signal Transduction Laboratory in DIR. Robin received her PhD in molecular biophysics and biochemistry from Yale in 2009. and she completed her postdoctoral training at NIDDK on the main campus in Bethesda before joining NIEHS as our first Earl Stadman tenure track investigator in 2014. Dr. Stanley's become an internationally recognized scientist in the fields of RNA processing and structural biology. Her lab utilizes an integrated approach combining structural biology methods, including cryo-EM, with in vitro reconstitution, biochemistry, and cell biology to uncover the structure, function, and regulation of fundamental RNA processing machines. Dr. Stanley has built a research group at NIEHS from the ground up, focused on defining how large RNA processing machines drive and regulate ribosome production. Last year, in response to the COVID-19 global pandemic, she pivoted her research to focus on viral RNA processing machines of the SARS-CoV-2 virus. In a little over a year, her lab solved numerous structures of a viral endoribonuclease and used biochemistry to define the mechanisms of viral RNA processing. And in recognition of her many accomplishments, she was promoted to senior investigator with tenure in April of this year. Her talk today is entitled SARS-2 NSP15 is Mad About You. This is a title which is taken from a paper that she recently published in Nature Communications. So without further ado, let me turn things over to Robin.
Great. Well, first of all, thank you, Daryl, for that really nice introduction. And can everybody hear me and see my slides?
Yes.
All right, great.
We both hear you and see your slides.
Well, as Daryl mentioned, today I'm going to share with you a story that really is a total research pivot for my group about something I knew nothing about a year and a half ago. So I'm going to tell you how we've discovered a particular viral protein is mad about you. But before I jump into virology, I wanted to start with actually a real quick introduction to my lab and what we study under non-pandemic times. So when I started my lab here at the NIEHS back in 2014, we were really focused on one molecule in particular. This happens to be my favorite molecule, the eukaryotic ribosome. And while the ribosome really needs no introduction, I'd just like to quickly remind you that ribosomes are these absolutely remarkable ribonuclear protein complexes that carry out the fundamental role of translating all of our mRNA to protein. All you have to do is look at the structure of this rotating ribosome molecule to really appreciate what a complex piece of machinery this is. Ribosomes are composed of many different parts, including 4 different ribosomal RNAs and 79 different ribosomal proteins. And all of these different components have to come together in just the right way so that the ribosome can carry out its job of making all of our protein. And so over the last 7 years, my lab has been focused on trying to answer this very big and very basic question of how do our cells actually put together the ribosome? And I think this is a really important biological question for many reasons. So first and foremost, ribosomes are absolutely fundamental for cellular function. And you have to have ribosome production to promote cell growth, differentiation, and development. And in fact, a rapidly growing cell devotes more energy to the production of ribosomes than it does to any other cellular process. So it's the major consumer of the cell's budget. Now, as a result of this high energy demand, rates of ribosome production are subject to stringent control. And it's highly responsive to environmental stress, nutrients, energy status, as well as growth factors. And what this stringent control allows a cell to do is to fine-tune rates of ribosome production to match the current environment of the cell. However, when this process becomes dysregulated, resulting in the over or underproduction of the ribosomes, this can lead to human disease. So for example, overproduction of ribosomes is a hallmark of cancer, and the underproduction of ribosomes resulting in reduced translational capacity is a hallmark of a group of inherited disorders known as ribosomopathies, as well as several neurodevelopmental syndromes. And so I think it's for all of these reasons why it's really important that we understand the basic molecular mechanisms of how our cells build and assemble the ribosomal subunits. And so the overarching goal of my lab is really to focus on defining these fundamental mechanisms. And it's my hope that by defining these fundamental mechanisms, we're going to be able to understand how the environment impacts this important pathway and how dysregulation of this pathway impacts human health. Now, had this little guy not decided to appear a year and a half ago, I would be talking to you today all about the ribosome. But instead, I'm going to be telling you about this pivot that we took starting in March of last year. And so I'd like to take you back to March of 2020. And so I vividly remember the day when we got the email that said, please shut your lab down. We're transitioning to remote work only. And so at the very beginning of the pandemic, I didn't think that I would have anything to do with COVID-19 research because I study eukaryotic RNA processing. However, after a few days of working from home, I really started to think, well, maybe there's something that we could do. And so I gave myself a crash course in coronavirus virology. And so I'd like to quickly walk you through the life cycle of the coronavirus, which I'm sure many of you are now very familiar with. So of course, the first step in the life cycle is that this viral particle has to attach to a receptor on the host. And this, of course, is mediated by the spike protein, which coats the surface of the viral particle via the ACE2 receptor on the host. Once this attachment is made, this triggers a conformational change, which allows that viral particle to be endocytosed into the cell. Then the virus is going to be uncoated, and this is going to release the genomic RNA inside the host cell. Now, all coronaviruses are positive sense RNA viruses. And so what this means is that the genomic RNA is of the coding strand. And so it is immediately ready to go for translation when it enters the host. So this viral RNA is going to be translated by host ribosomes, and this produces 2 large polypeptides, which are then proteolyzed into 16 different non-structural proteins. And these non-structural proteins play very important roles in forming these double membrane vesicles and also play important roles in replicating the viral genome, as well as in transcription of the soaked genomic RNAs, which of course encode the so-called structural proteins, which go on to become part of the mature viral particle. And as I started to think about this pathway, I realized that there are a lot of similarities between sort of the coronavirus and ribosome production. Of course, both pathways involve the transcription of a lot of RNA, and both pathways involve many different RNA processing factors. So the RNA processing factors from the coronavirus are all these non-structural proteins, and there's many different ones, including an RNA-dependent polymerase, an RNA helicase, exonuclease. But the one that really jumped out at me when I started learning about these proteins was the protein called NSP15, which is so named because it's the 15th protein in the viral genome. And NSP15 encodes for an endoribonuclease. Now, the reason that this protein jumped out at me is because NSP15 shares a number of characteristics with 2 other nucleases that we've been studying in my lab. These are nucleases, one that's involved in processing ribosomal RNA, and another that's involved in processing pre-tRNAs. The first similarity that jumped out at me between all 3 of these enzymes is that all of these enzymes rely on oligomerization for nuclease activity. Very perplexing thing about NSP15 is that it actually has to form a hexamer to be active. All of these nucleases also appear to cut the RNA in a very similar fashion. And they cut the RNA via a metal ion independent reaction, which produces these unusual cleavage products that contain a 2'3' cyclic phosphate and a 5' hydroxyl. And if we were to zoom into the active sites of all 3 of these nucleases, all of the nucleases cut the RNA utilizing a series of conserved residues within the active sites, most notably a histidine residue that promotes this general acid-base catalysis. So at the end of the day, when I really thought about it, I'd already been studying this reaction for 7 years. I'd just been studying it through the lens of nucleases that are involved in other biological pathways. So just to tell you a little bit more about NSP15 and its role in the coronavirus. So NSP15 is found in all coronaviruses and most nidoviruses. So this suggests that whatever NSP15 is doing for the virus, it's really important for positive stranded RNA viruses. We know from in vitro biochemistry that NSP15 cuts both single and double-stranded RNA, and it does so with an interesting specificity, and that is it cuts the RNA backbone 3' of uridines. As I already mentioned, NSP15 is only active as a hexamer, but the mechanism of RNA processing was very poorly understood when we started working on this project. Now we know that somehow NSP15 is doing something to modulate the host immune response. And this happens via the double-stranded RNA sensor MDA5. And so when you have a variant of the coronavirus that has an inactive copy of NSP15, this leads to the massive stimulation of MDA5. And my postdoc, Meredith Frazier, came up with a really clever analogy to help you remember how what NSP15 is doing. And that is that you can think of NSP15 as a so-called viral invisibility cloak. And so when the virus has an active copy of NSP15, it's going to process the RNA and really allow the RNA to sort of sneak around in the host undetected. But when you inactivate NSP15, suddenly the host sensor is able to sense that RNA. It's also been shown in multiple animal variants of coronavirus that if you inactivate NSP15, these variants show massively reduced viral pathogenicity, suggesting that NSP15 is an excellent target for antivirals. All right, and so after my quick lesson in virology, I thought, okay, there's enough similarity here that perhaps we can take the same approach that we've been taking to study these other nucleases and apply that to studying NSP15. So I wrote a very short proposal. I submitted it to a committee in Bethesda. It was approved within 24 hours. And then we were ready to go in the lab to get working on this project. And so the first step in getting this project to work was I needed to recruit some volunteers from my lab. And so when we were in this COVID-19 shutdown period, we were only allowed on the NIH campus to do COVID-19 research only. And so this was done entirely on a volunteer basis. And so I reached out to my lab and I said, does anyone want to volunteer to work on this project? And absolutely every member of my lab volunteered. And so we embarked on a group lab-wide project focused on studying NSP15. And so in just a couple weeks' time, we were able to produce a recombinant SARS-2 NSP15. And as expected, we could purify the hexameric form of the protein. We took the fraction containing this hexamer and we immediately took it to the electron microscope. And I think we really lucked out here. NSP15 has really been a textbook perfect sample for cryo-EM. And that's probably because the size and shape of the particle, this hexamer is around 240 kilodaltons and it has 6-fold symmetry. We get this absolutely beautiful distribution of particles. Less than 24 hours after putting our first grid into the microscope, we were able to get our first reconstruction to around 4 angstrom resolution, which is definitely a record in my lab that I doubt that we will ever break. And over the last year and a half, we've really been able to hit a number of milestones with this project. And so what I'd like to do with the rest of my time today is to really walk you through some of our big discoveries about how NSP15 works. So the first 2 questions I'd like to focus on this afternoon are how does NSP15 achieve its specificity? So remember, NSP15 is only going to specifically cut RNA 3' of uridines. Before we started working on this project, it was really poorly understood how it achieves that specificity. And then how does NSP15 actually come along and cut the RNA? So to answer these first 2 questions, I'd like to start by showing you a cryo-EM structure of NSP15 bound to a uridine monophosphate. So this is what the overall structure of NSP15 looks like. So again, it's a hexamer, but it has an unusual arrangement. So it's arranged as a trimer of dimers. And so there's a trimer on top and a trimer on bottom. This results in 6 independent nuclease active sites. Now within our UMP bound structure, we were able to observe a UMP in each of the 6 active sites, and I've got one of them boxed here. So now I'd like to do is to zoom in to one of those active sites. So here you can see how we were able to model the UMP within the active site. We also had some extra density that we modeled as a phosphate. So now let's go to that first question. So how does NSP15 recognize uridine? So what I'd like to do is strip away everything but the uracil base. So anytime you have something that concerns nucleotide specificity, it almost always comes down to specific hydrogen bonding interactions. And if we look at our NSP15 structure, that's exactly what's going on in NSP15. This uracil is specifically recognized by NSP15 via one particular amino acid, this serine 294, which makes specific interactions with the uracil base. And the serine 294 is sort of held in place in the active site by another residue, asparagine 278. And this was great to see because it had actually been predicted a number of years ago from SARS-1 that this serine residue was likely the key discriminator for uridine specificity. So it's nice to see that in our structure. And I don't have time to show you the data today, but we've gone on and mutated this residue and shown that it's absolutely critical for cleavage activity. And interestingly, this asparagine residue is absolutely critical for maintaining uridine specificity. All right, so now let's move to the next question. So how does NSP15 actually cut the RNA in half? So I already mentioned that an active site of NSP15 contains a well-conserved histidine residue. Well, actually, NSP15 contains two well-conserved histidine residues. In SARS-2, this is histidine 250 and histidine 235. Histidine 250 in our structure, you can see, is within hydrogen bonding distance of the 2' hydroxyl of the ribose. And the other histidine, histidine 235, is within hydrogen bonding distance of where we modeled a phosphate into the active site. To confirm the significance of these histidine residues, we mutated them to alanines and showed that they're both absolutely essential for NSP15 nuclease ability. But to really understand what these histidine residues were doing to cut the RNA in half, I need to very quickly introduce you to another nuclease. And that, of course, is RNase A. So RNase A happens to be probably the most well-studied nuclease of all time. And as a result of this, we know an awful lot about how it works. So NSP15 and RNase A share a catalytic triad. And so both these enzymes have two histidines in the active site as well as a critical lysine residue. And what I'm showing you here is a superposition of the active sites of these two proteins, and you can see that they are very similar. Now, outside of the active site, there's really no sequence or structural similarity of these two proteins, but the active sites themselves are super duper well conserved. So I'd like to walk you through the reaction mechanism of RNase A. So RNase A cuts the RNA via a two-step reaction. So in the first step of the reaction, one of these histidine residues is going to function as a general base, and it's going to protonate the hydroxyl off the 2' hydroxyl, right? And what this is going to do is then allow this to act as a nucleophile to attack the phosphate. This reaction is called transesterification, and what it's going to do is going to result in two products, one containing this 2', 3' cyclic phosphate, and the other containing a 5' hydroxyl. Now, RNase A does not stop there, and it actually catalyzes a second step of chemistry. And that's where this other histidine residue is going to come into play. With the aid of a water molecule, this histidine is then going to resolve that cyclic phosphate, and the final product produced by RNase A is a piece of RNA containing a 3' monophosphate. Now, because the active sites of RNase A and NSP15 are so similar, we really wanted to know, does NSP15 cut the RNA in the same way? And just to help you understand this mechanism, you don't need to understand all the details, but you can really think of it as being a big cut that cuts the RNA in half, and a little small snip that sort of resolves that cyclic phosphate. All right. So in order to be able to test if NSP15 is doing the same thing, we needed a way to actually distinguish these two products. So a cyclic phosphate from a monophosphate. And one of the best ways to do this is actually by mass spectrometry. And so we turned to the mass spec core at the NIHS, and we asked if they could help us resolve the cleavage products of NSP15. And so what I'm showing you here is a spectra of the 3' cleavage products. And we were actually able to detect both the 2', 3' cyclic phosphate and the 3' monophosphate products. And so that immediately told me that yes, NSP15 can cut the RNA just like RNase A via this two-step reaction. However, we always observed a much larger percentage of the cyclic phosphate product than the monophosphate product, whether we did a protein titration or a time course. And so my interpretation of this data is that that second step of chemistry, the hydrolysis step within NSP15, is actually very slow. And so if we go back to this comparison of NSP15 with RNase A, I think I can actually tell you why that is. And remember, this hydrolysis step is going to be driven by this other histidine residue. And if you look at the position of the histidine residues within RNase A and NSP15, you can see that these two histidine residues are about 9 angstroms away from one another. And so I think it's the suboptimal positioning of this other histidine residue that's why hydrolysis within NSP15 is likely slowed down. All right, so the next question that we wanted to tackle was this issue of hexamerization. So we know that NSP15 has to oligomerize to be active, but I just showed you the active site, and that's contained within a single monomer. So why does it need to form a hexamer when everything you need for catalysis is contained within a single active site? So to answer this question, I'd like to show you a couple cryo-EM structures of apo-NSP15. So this is NSP15 in the absence of a ligand. So we've solved a number of structures of apo-NSP15, and overall these structures are very, very similar to the UMP-bound structure, with one notable exception. And that is when we looked at the density for these apo structures, the density for the nuclease domain in all cases was very poor. Now, poor density in cryo-EM can often be indicative of something known as conformational heterogeneity. So basically what this means is that the protein is sampling multiple conformational states on our cryo-EM grids. I think a really great way of thinking about this is if you've ever tried to take a picture of a little kid and they're waving their hand. When you take the picture, their hand is going to be fuzzy. So it's the same concept here. We're trying to capture snapshots of NSP15. We can't capture a high resolution snapshot of the nuclease domain because it's moving around. An easier way of seeing this is we were actually able to do some fancy analysis of our data and pull out 20 different conformational states of NSP15. And what I'm showing you here is just a rigid body model of each of those 20 different conformational states. So the other two domains of NSP15 you can see are really fixed and they are not moving, but this nucleus domain is really moving about within our cryo-EM grids. It's not undergoing massive opening and closing. It appears rather to be undergoing more of a wobble-like motion. In order to confirm that what we saw by cryo-EM was not an artifact of cryo-EM grid preparation, we turned to Lelith Pereira in the computational chemistry core and had him help us with some molecular dynamics simulations. So what I'm showing you here is something called the dynamic correlation. So the dynamic correlation is a measure of how well one region of a protein correlates its motion to another region of the protein. And so here is the dynamic correlation for monomeric NSP15. And you can see that basically monomeric NSP15 has no dynamic correlation. So monomeric NSP15 is very dynamic and very mobile. So it's likely very unstable. So if you compare this with hexameric NSP15, you can see that we see an increase in the dynamic correlation within the hexamer. And you see that parts of the protein now start to correlate their motion with other parts of the protein. But if you compare the hexamer with no ligand bound and the hexamer with a UMP in the active site, you can see here that we see this massive increase in the dynamic correlation of the protein. And this really nicely matches what we see by cryo-EM, and that is that in the absence of a ligand, the nuclease domain is more flexible, it's more dynamic, but when you have a ligand bound, it's more fixed into position. And so to summarize what I've told you thus far, we think that at least one reason that NSP15 relies on oligomerization is for stability, because the monomer is very dynamic and very unstable. In the absence of a ligand, the nuclease domain is wobbling about in solution, but once RNA binds to the active site, it locks it into position. And once it's locked into position, this allows NSP15 to do its job, and it's going to cut the RNA via this two-step reaction of trans-esterification and hydrolysis. However, this step of hydrolysis is very slow. Okay. So the next question that we wanted to tackle about NSP15 function was to actually bring it back to the virus. And we really wanted to understand what parts of the viral RNA is NSP15 actually targeting for disruption. And so I'd like to highlight some work from another lab. And this is the work of Susan Baker. And Susan Baker was able to identify at least one target of NSP15, and that is this string of poly-Us on the negative strand. Now, I mentioned earlier that coronaviruses are positive strand RNA viruses. So here we have our positive strand RNA virus, and the positive strand is going to terminate with a poly A tail, like a regular mRNA. But in order to make a lot of copies of this viral genomic RNA, the first thing that the RNA polymerase has to do is it has to make a template strand. Of course, the template strand is what we call the negative strand. Because the positive strand terminates with a poly A tail, the negative strand actually begins with this string of Us. And what the Baker lab was able to show is that if you inactivate NSP15, you accumulate Us on the negative strand, and that this can actually elicit an immune response. And so we wanted to see if our recombinant NSP15 was active on a poly-U containing RNA. And so we took 17 mer of RNA that was labeled on one end, and we incubated it with our recombinant NSP15. And you can see that in the course of a 30-minute reaction, NSP15 completely destroys this piece of RNA. We also took a longer piece of RNA, and so we took the entire length of the negative strand at the 5' end, which contains 29 Us, and we went about 20 additional nucleotides into the negative strand. You can see that NSP15 completely chops off the poly-Us from the negative strand, but it's also able to cut additional Us within the negative strand. So not only can NSP15 chop the poly-U tail, but it can also cut additional Us within the sequence. So another group took a different approach to identifying NSP15 viral RNA targets, and they took a high throughput sequencing approach. And they utilized a sequencing method where you ligate adapters to those unusual ends, those cyclic phosphate products. And by the sequencing method, they were actually able to identify a number of NSP15 targets throughout the positive strand. And from a comparison of all the targets that they identified, this suggested that NSP15 might have some specificity beyond U, because they noted that cleavage between a U and an A was the most common product that they observed. And so the final question that I'd like to answer today is there any specificity beyond U? So beyond recognition of the uridine, is anything else guiding NSP15 to its viral cleavage products? So to answer this question, I'd like to show you a couple more structures of NSP15 that we've determined in the presence of longer pieces of RNA. So the first structure that we determined is a structure of NSP15 bound to a trimer of RNA in the pre-cleavage state. So to prevent catalysis from happening, we modified the U so that cleavage couldn't occur. We were able to visualize the U within the active site. It goes to the exact same position that we observed in our UMP structure. And while the U was well resolved, we couldn't observe any additional density for the A on either side of the U. We were also able to solve a structure of NSP15 in the post-cleavage state. And to capture this state, we took recombinant NSP15 and we incubated it with a trimer of RNA. And in this case, we didn't modify the U so that cleavage could occur. And we were able to capture a structure of NSP15 with the 3' monophosphate product. And we could visualize both the U and the A just before the U. The U is exceptionally well ordered. In fact, this structure was resolved at 2.2 angstrom resolution, which is our current record by cryo-EM in the lab. And we also observed weaker density for the A. But if we look at both our pre and post cleavage structures, while they told us a lot of insight into the mechanism of RNA cleavage, we didn't observe any extensive RNA recognition beyond the U. And so these structures didn't help us explain any further specificity with NSP15. One nice thing about the structures is that the R2 structures, along with the crystal structure of the cyclic phosphate product from a structural genomics group, really show the complete catalytic mechanism of NSP15. And I don't have time to walk you through that today, but through our structures and a lot of site-directed immunogenesis, we've really been able to uncover the role of all of these critical active site residues. Let's go back to this issue of specificity. So our structures didn't tell us anything more about specificity. And so instead of using structural biology, we turned to some biochemistry and looked at the RNA itself. And so a postdoc in my lab, Meredith Fraser, was able to develop a FRET-based assay to study nuclease activity. And so in this assay, what she did was she positioned a uridine here, what we call the B-1 position, and then she modified the base either before or after the uridine. And what she found was that when you modify the base before the uridine, this largely has no significant impact on NSP15's ability to cut the RNA. So NSP15 doesn't appear to care what is the nature of this particular base. However, when Meredith modified the makeup of the base after the U, we suddenly saw a difference. So NSP15 doesn't seem to distinguish between an A or a G, but if you put a C after the U, you can see that this massively reduces NSP15's ability to cut that RNA, suggesting that yes, it does have some specificity beyond simply looking for a uridine. So we also wanted to apply this to studying a piece of the viral RNA itself. And so we selected a piece of the positive strand called the transcriptional regulatory sequence. So the transcriptional regulatory sequence is an important piece of the genome that promotes this unusual thing that the RNA polymerase does called transcriptional skipping. So we took the transcriptional regulatory sequence from the spike protein, and the sequence is shown here, and you can see that there are several uridines within this sequence. We labeled it on both ends, and then we were able to resolve the products on a denaturing urea gel. And what you can see is that we could detect cleavage products at all 4 uridine positions. However, you can see that some are more preferred over others. And I'd just like to point out this one in particular, this U4 position lies between a U and a C. And you can see that this one is not as preferred as U6, which lies between a U and an A. And this really nicely agrees with Meredith's FRET-based assay, which shows that NSP15 doesn't like to cut between U's and C's. So if we put all of this information together, I think we can have a nice working model for what NSP15 is doing. And really, NSP15 appears to be a very general purpose endonuclease that's very mad about one specific nucleotide, and of course, this is U. Most of what is driving NSP15 to its cleavage targets is that recognition of the uridine within the active site. However, it does appear to have some degree of specificity in that it will cut U's and UA and UG over a UC. NSP15 can also cut 3' of C's, but it has a massive preference for cutting 3' of U's instead. And I think if we bring this back to what NSP15 is doing to the virus, I think it's probably very important that NSP15 has this very broad cleavage ability, because what NSP15 is doing is it's preventing the accumulation of too much viral RNA. So if NSP15 was wired to just cut a couple different places within the genome, it really couldn't fulfill its job. And so you want NSP15 to be able to cut whatever part of the RNA is accumulating too much so that it, again, masks the RNA from the host immune response. And I think this is an interesting fact, but uracil actually happens to be the most abundant nucleotide in the coronavirus genome. And so I think it's intriguing that all coronaviruses have a nuclease specifically wired to cut after use. And so when I started this project a year and a half ago, I had no idea how long we would work on this project, but now I'm really, really intrigued. And there are many, many more questions that we'd really like to be able to ask and answer. And I don't have time to read these all out to you, but I'll just say that the 2 big things that we're looking into now are trying to understand what regulates NSP15 activity. So I just told you that NSP15 will cut RNA with a piece of U. And so clearly there has to be regulatory mechanisms at play to prevent NSP15 from going crazy on all types of RNA. And the other thing that we'd really like to be able to do, of course, is to use our structures to aid in the design of new antivirals, which of course are urgently needed. And so just for fun, I made a little movie that kind of illustrates what we've learned about NSP15 thus far, and hopefully this sound is going to work. But this movie is set to a song I think you'll recognize from the musical Grease. You better shape up, 'cause I need a man. My heart is set on you. You better shape up, you better understand. To my heart I must be true. Nothing left for me to do. You're the one that I want. right, with that, I'll end by thanking all of the members of my lab. What started out as a group project, of course, has now evolved to a project that's led by a postdoc in my lab, Meredith Frazier, and a great postdoc, Aisha Wilson. And none of this would have been possible without the support of the numerous core facilities here at the NIHS, including the structural biology core, the cryo-EM core, the mass spec core, and the computational chemistry core. And with that, I will thank you for your attention, and I'd be happy to take any questions.
So great job, Robin. You're a classic example of how nimble intramural program allows investigators to change gears to respond to a global pandemic and just do amazing research and also make a movie. So I think we'll open it up for questions. We have lots of hands up. So let's start with Karen, then Terry, and then Rick.
Okay. Thank you, Robin. That was really beautiful work and really well put together talk. I learned a lot. I have two questions, just quick questions, but I may have missed this. So NSP15 is a hexamer, but why? So you say it's a dimer of trimers, right? Would one trimer? So the monomer you say is unstable, so it's bound to prevent degradation. And is that the stability you're talking about, or so it's more stable in the active site so that it's not so loosely defined? But in that case, if that's the case, then if it is loosely defined, I mean a loosely defined active site, a loose active site, if you will, in the monomer, wouldn't that be able to cleave maybe something less specific, so more RNA than more bases than just you?
Yeah, so that's a great question. So first question, activity related to forming a hexamer. So it appears it has to be a hexamer. We have a couple mutants that we've been able to make that form trimers instead of a hexamer, but they do not appear to be active. This appears to be unique to the coronavirus. So there are other endo-Us that are found in other viruses. So for example, there are some versions of the nidovirus that have an endo-U enzyme, but it's not a hexamer, it's actually a dimer. So this issue of oligomerization seems to be unique to coronaviruses. I didn't have time to go into it today, but we can actually see in our structures that have a longer piece of RNA bound that RNA actually binds at the interface. And so I think another very, very important reason for oligomerization of the protein is because you need to create this larger surface where the RNA can go.
Okay, and so that leads to my second question. So because you do see sequence selectivity as far as nearest neighbors, is that due to steric hindrance, do you think, or is that from secondary structure of the RNA?
It's probably a little bit of both. So we have a new structure, which I didn't show today, with a much longer piece of RNA. And I'm hoping that's going to, as we're building and refining it, I hope that's going to shed some more light. But it's probably a combination of both what will fit in the active site and both the structure of the RNA itself.
Great. Thank you very much.
Thanks.
Terry?
Robin, really wonderful work. I'm wondering, viruses have these clever ways of hijacking cellular biochemistry and sometimes superseding the endogenous reactions to favor their own. Is there any evidence that there's some mechanisms that NSP15 is engaging in that helps to minimize host mRNA processing and maybe even degrading host mRNA relative to what happens with the viral RNA?
Yeah, that's an excellent question. So this was hypothesized a number of years ago that maybe one of the ways that NSP15 is working is actually by degrading mRNAs associated with the immune system. However, this group, Jay Hasselberth lab from the University of Colorado that did this sequencing method in the last year, did not detect any cleavage products within the host. So it appears that NSP15 is really only targeting the viral RNA. And one of the reasons this might be is because during coronavirus replication, most of the replication is thought to take place within these double membrane vesicles. And it's thought that NSP15 is localized within these double membrane vesicles. And probably what that's doing is it's keeping NSP15 enclosed in this vesicle so it doesn't have access to all of the cellular RNA. Because of course, if it had access to that cellular RNA, I imagine it would chop it up.
Rick?
So Karen and Terry asked my first two questions. I'll ask the third, a simple one. Are there any sequence variations in Delta that are associated with may have been a more aggressive, or is NSP 15 a target for specific mutations that may somehow relate to the infectivity of the virus?
It's a great question, one that I have been wanting to answer. And so we reached out to Jason Lee from the Bioinformatics Corps, and we had him analyze over 1 million variants of COVID-19 that have been deposited in this GISAID database. And it's not like the spike protein, like I don't think NSP15 is going to mutate as much as the spike protein, but we do detect a number of variants of NSP15. And actually what my postdoc Aisha Wilson is doing in the lab right now is going and making all of these mutations and seeing what effect that has on NSP15 activity. And of course, we assume that some of these will be more active, some will be less active, and probably some won't really impact the function. But I can't wait until we complete our analysis, because I think this is a really interesting question.
Very, by the way, what terrific work. It's just absolutely amazing what you've been able to do in the relatively short time frame.
Trevor?
Wonderful talk. I was just so excited to hear it. I mean, a great job in such rapid time, unbelievable. My question was about inhibitor design. So you indicated that the slowest step was this hydrolysis step. So obviously, when you think about inhibitor design, you always think about going after the slowest step. So have you any thoughts about how you might just target that hydrolysis step?
So the only work, well, I should say not the only work, tons of papers have been published in the last year and a half. They've done all kinds of in silico docking and proposed all sorts of things that might be an inhibitor of NSP15. Of course, that's all purely computational. And so, we've gotten a number of those. We need to go into the lab and see if they actually do inhibit. The one inhibitor that does seem to show some progress in inhibiting NSP15 is actually tapiracil, which is already an FDA-approved drug, and it's a uracil derivative. And so I think uracil derivatives would be obviously great targets for NSP15 because, of course, they're going to bind right into the active site. Now, this issue of targeting the slow step, I think, is intriguing, but maybe not be the right approach for NSP15. And that's because I don't think it matters whether or not that second step of chemistry happens. So all NSP15 needs to do is cut the RNA in half. And so it succeeds in doing that with the first step of chemistry. And so my guess is the reason that NSP15 is not very good at hydrolysis is because it probably doesn't matter. I think in RNase A, actually, it's a binding and rebinding that causes the second step. And so probably, I don't know that would be the best step to target because I don't know that it really matters whether it does hydrolysis or not. But if we think about the active site, I think these uracil derivatives for now are probably our best bet. Another thing that I think would be really intriguing for inhibitor design would be something that disrupts the oligomerization of the protein. And so we identified a number of interfaces from our hexamer structure that might also be other areas where you could sneak in a small molecule or a peptide to sort of break that up.
Maybe the last question, Robin asked a question in the chat. Robin, do you want to go ahead and ask that as the last question?
Yeah, I think that was answered well with the vesicle separation of the host. That's a good thing.
All right, with that, I think we'll turn things back over to Gary. Wonderful presentation, Robin, and back to Gary.
Thank you, Daryl, and thank you so much, Robin. That was a wonderful presentation. And there are comments in the chat as well, just saying how fantastic the work is and wonderful presentation. So I just want you to know that. So we're at the end of our schedule for today. Rick, do you want to say a few words before we part?
Well, we're actually running a little bit over, so I am going to be very brief. I just want to thank everyone for your participation in all parts of the meeting today. I think it was pretty exciting, and I think this is another example. This was the best yet. And thanks to Gary and his colleagues and DERT and all members of council. Very engaging, lots of terrific science that we talked about, and I look forward to seeing you all again next time. And I see that Pat has his hand up. Do you have a final comment before we adjourn?
Yeah, if you don't mind, I just want to say thanks to all people who make council work. Liz McNair, as we all know, and Rose Moody that works with her, all the administrative staff that are doing all the paperwork to get you all here virtually. And of course, the ITAV guys, Nathan and Paris, who make all this work. And Paris had to step in like Thursday of last week to take over for John Maruka, who couldn't do it. So thank for all the work they do, and I think they do a great job. So.
Okay, well, terrific. Have a great evening, everyone. And have a great fall. And I look forward to seeing you all in February, hopefully in person.
One more thing. Yeah. One more thing. I just want to as well add Pat to that list of folks that he mentioned. You took the words right out of my mouth. So thank you, Pat, for all your work. And I appreciate all of you on the call today for your engagement. We really did have some great discussions, particularly around climate change. And I'm excited for what the future holds and what we can do there. And with that, actually, Rick, we are ahead of schedule. We're scheduled to end at 5:15. So
okay, great.
We're ending a little early today.
So this is noteworthy. We're ending a Zoom session early. And just for members of council, pay attention to any possible interim meetings that we may have to approve some concepts around climate change and health. So stay tuned. Things are moving quickly, and we look forward to engaging with all of you, getting your ideas and continuing to move things ahead. Okay, thanks everyone.
Thank you.
Take care.